Hey yo, let's rap UM, let's rap more.
PKKMB Lenceng.
Ciro lupa. Selamat datang kawan di kota pendidikan, Universitas Negeri Malang. Belajar di sini untuk cita impian. Salam cakrawala, itu milik kita.
Percaya diri untuk raih prestasi, tunjukkan jati diri, wujudkan imajinasi. Bergerak selalu, tak pernah diam, giat berkarya untuk capai cita.
Wawasan luas adalah jawaban. That's right. Untuk menggapai masa depan. Pribadi yang bekerja dan saling menghormati pada setiap pribadi tak terkecuali.
Kecerdasan adalah kemampuan untuk adaptasi dalam perubahan.
Universitas Negeri Malang, berkarya dan terus berkarya. Universitas Negeri Malang, lambungkan asa menuju cita.
Universitas Negeri Malang,
inovasi tiada henti. Universitas Negeri Malang, lambungkan prestasi untuk negeri. Belajar itu penting, jangan dibawa pusing. Baca buku yang sering, walaupun ongoing. Semangat mencapai impian dengan belajar dan terus belajar. Walau rintang dan silih berganti, tetap hadapi dengan hati yang sabar. Makan nasi rasanya hambar, hati boleh ambil, tetapi prestasi harus tetap ku kerja.
Pengertian dan pengalaman, mampu dan adil untuk jalankan kewajiban. Tak kenal lelah, untuk pengalaman yang banyak, jujur dan bijak dalam bertindak.
Beradaptasi dengan sekitar, bagai mentari yang sedang berpijar. Jadi diri sendiri, gak perlu basa-basi. Kenali diri tuh, kembangkan imajinasi. Universitas Negeri Malang, berkarya dan terus berkarya. Universitas Negeri Malang, lambungkan asa menuju cita. Universitas Negeri Malang, inovasi tiada henti. Universitas Negeri Malang, lambungkan prestasi untuk negeri. Universitas Negeri Malang, berkarya dan terus berkarya. Universitas Negeri Malang, lambungkan asa menuju cita. Universitas Negeri Malang, inovasi tiada henti. Universitas Negeri Malang, lambungkan prestasi untuk negeri.
Halo, assalamualaikum warahmatullahi wabarakatuh. Kali ini saya berada di Universitas Negeri Malang, mau muter-muter pakai drone melihat UM dari atas. Oke, langsung saja.
Mathematics Department, Faculty of Mathematics and Natural Sciences, Universitas Negeri Malang has hosted ICoMathApp annually as a platform to the research, expert, and practitioner to share knowledge and insight on algebra, analysis, applied mathematics, combinatorics, computational sciences, geometry, statistics, actuarial sciences, and mathematics education. I am Sefira,
And I am Muhammad Nur Ramadan.
your host of this today's conference.
Well, ladies and gentlemen, allow me to read the agenda of today's opening ceremony. The first one will be singing Indonesian national anthem, Indonesia Raya. The second one will be welcoming and reporting speech by Chairman of ICoMathApp 2023. The third one will be welcoming an official opening speech by Dean of the Faculty of Mathematics and Natural Science. The next one will be opening prayer, and the last one will be photo session.
Honorable guests, ladies and gentlemen, now we invite you all to sing the Indonesia National Anthem.
Attendees are requested to stand up. Hadirin dimohon untuk berdiri. Attendees are requested to sit down. Hadirin dimohon untuk berdiri. Mohon maaf, maksud saya dimohon untuk duduk kembali. Well, ladies and gentlemen, next we will listen to the welcome address and report from Mrs. Jamaliatul Badriah, PhD, as the chairperson of the fourth ICoMathApp. Mrs. Jamaliatul Badriah, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, all participants. The Honorable Dean of the Faculty of Mathematics and Natural Sciences, Professor Dr. Hadi Suwono, the Honorable Head of the Mathematics Department, Latiful Anwar, PhD, the Honorable Keynote Speaker, Dr. Budi Arta Surya, Mr. Luigi Pobio, Professor Peter Grootenboer, Professor Dr. Bhakti Stefan Onggo, and Professor Susiswo, and the Honorable all speakers and participants of ICoMathApp 2023. On the behalf of the organizing committee, I would like to thank you and welcome you all to the 4th International Conference on Mathematics and its Application 2023. This year's conference theme, Mathematics and its Application on Society 5.0, Challenges and Opportunities, resonates deeply with the ever-evolving landscape of our world. Society 5.0 envisions a harmonious vision of cutting-edge technologies and societal well-being, striving to create a smarter, more sustainable, and human-centric society. And at the heart of this transformation lies mathematics, the timeless language of patterns, logic, and relationships. Our collective journey through this conference will not only enrich our understanding of the intricate world of mathematics, but will also shed light on its pivotal role in shaping Society 5.0, from AI-driven advancement to the digital revolution, from precision addition to sustainable energy solution. Mathematics serves as the cornerstone of innovation, providing the essential tools to address challenges and seize opportunities. This conference is not just a gathering of minds, but a convergence of aspirations, where we come together to ignite discussions, foster collaborations, and inspire breakthrough. The interaction we engage in and the knowledge we exchange will echo far beyond these walls, influencing the way we approach research, education, and problem solving in the realm of mathematics. So, as we embark on this exciting journey, let us keep the spirit of exploration alive, embracing the challenges with determination and seizing the opportunities with fervor. May this conference, ICoMathApp 2023, be a beacon of inspiration, fostering a synergy between mathematics and the grand visions of Society 5.0. Thank you very much for your participation, and I wish us all a truly enlightening and transformative conference ahead. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much, Mrs. Jamaliatul Badriyah, for the words.
Honorable guests, ladies and gentlemen, the 4th ICoMathApp is going to be officially open. We'd like to invite the Dean of Faculty Mathematics and Natural Sciences, Professor Dr. Hadi Suwono, MSI, to deliver the opening speech and open the seminar. For Professor Dr. Hadi Suwono, the time is yours.
Thank you so much, MC. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The honorable keynote speakers, Professor Budi Arta Surya, Professor Luigi Pobio, Professor Peter Grootenboer, Professor Bhakti Stefan Onggo, and Professor Susiswo, the Honorable Head Department of Mathematics, Latiful Anwar, PhD, and all of colleges from the Mathematics Department, the Honorable speakers and participants of ICoMathApp 2023. With great honor and enthusiasm, I welcome you to the International Conference of Mathematics and its Application 2023 under the theme Mathematics and its Application in Society 5.0, Challenges and Opportunities. This gathering stands as a testament to our unwavering commitment to unraveling the profound connection between mathematics and its practical impact on our evolving world. In an era where the boundaries between the physical and digital are becoming increasingly blurred, where innovation and sustainability harmonize, we find ourselves at the precipice of Society 5.0. It is a time when mathematics illuminates the universe, enriches, and serves as the bedrock of transformation solution that transcends disciplines. This conference serves as a crucible of intellect and innovation, fostering an exchange of ideas that will undoubtedly shape the trajectory of our collective future. We are here to explore the challenges that lie ahead and seize the myriad opportunities that mathematics afford us in navigating the complex landscape of technology, environment, health, and societal well-being. I would like to extend my heartfelt appreciation to the dedicated organizing committee of the Department of Mathematics, Faculty of Mathematics and Natural Sciences, Universitas Negeri Malang, for their remarkable efforts in orchestrating this event. Their commitment and diligence have ensured that we have a platform where innovation and dialogue can flourish. Over the next 2 days, we will be privileged to engage with some of the brightest minds in this respective field. Through insightful discussion, thought-provoking presentation, and collaborative dialogues, we shall uncover new perspectives that bridge theory and practice, aspiration and implementation. As we commence the conference, I hope you may draw inspiration from the mathematical elegance that underpins our work and find innovative pathways to harness its power for the betterment of Society 5.0 and beyond. And finally, in the name of Allah Subhanahu wa Ta'ala, Bismillahirrahmanirrahim, I hereby officially open the 4th International Conference on Mathematics and its Application, or ICoMathApp 2022. Once again, I extend my heartfelt welcome to each of you. Together, let us chart a course that propels the extraordinary potential of mathematics into the very heart of our rapidly evolving global landscape. Thank you very much for your participation, and let's enjoy the journey ahead. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much to the Dean Professor Hadi Suwono.
Well, ladies and gentlemen, we all expect guidance, wisdom, and support from God as we begin this conference. We would like to invite Dr. Imam Rafiki for prayer recitation. Mr. Imam Rafiki, the time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, let us bow our heads for a moment and pray to God Allah Subhanahu wa Ta'ala so that our international conference can be precious to all of us. I will lead this prayer based on the tenet of Islam, and those who are not Muslim, you are pleased to pray according to each of your beliefs. Alhamdulillahirabbil alamin. Hamdan syakirin, hamdan naimin, hamdan yu'afi ni'amahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yambahi li jalali wajhikal karimi wa adimi sultanik. Wa sallallahu ala sayyidina wa safi'ina wa maulana Muhammad wa ala alihi wa sahbihi ajma'in. Oh Allah, today we are present in this hybrid meeting at the International Conference on Mathematics and its application. Make this international conference a proper science as a medium for sharing valuable ideas, knowledge, and experiences of scholars, researchers, and students of various disciplines. Oh Allah, bless our hearts and our minds with the light of your guidance. Impart your supreme wisdom upon our activities. Help us to speak our minds clearly. Help us to listen to each other, respect each other, love each other, so that we are included to the blessed persons. Oh Allah, protect us from unintended temptation, show us the right path and give us knowledge and strength to perform good things. Equally, show us and make clear the wrong things and give us knowledge and strength to avoid them. Oh Allah, you are the one who can fulfill our prayers. Rabbana dolamna anfusana wa illam takfir lana wa tarhamna lanakunanna minal khosirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Amin, amin, ya Rabbal Alamin. Thank you so much, Mr. Imam Rofiki. May God bless us all.
Next, we're going to have a photo session. Please turn on your camera and set the conference virtual background. The operators will help us to take the photo. I will to lead the virtual room to take photo session. Okay, for the first slide, 1, 2, 3. In the next slide, 1, 2, 3. Thank you so much. We've got your pictures already.
And ladies and gentlemen, on the side attendees, don't be worried, we are going to have documentation too. So I would like to kindly request Professor Grootenboer and Professor Susiswo to stand in front of stage, and all the participants, please stand in front of stage because we have to have our documentation session too. Jadi Bapak Ibu sekalian, peserta dari conference ICoMath, dimohon untuk berdiri di depan panggung supaya kita bisa melaksanakan foto sesi untuk partisipan yang offline. Dimohon kepada Bapak Ibu untuk sama-sama berdiri di depan dan menyiapkan gaya terbaiknya.
Monggo Bapak Ibu dipersilakan.
Once again, for ladies and gentlemen, please stand in front of the stage because we have to have our documentation session on the side. On-site documentation. Sekali lagi kepada Bapak Ibu attendees, partisipan, peserta daripada ICoMathApp, dimohon untuk berdiri depan agar kita bisa mengcapture memorable moment ini bersama. Oke. Mungkin untuk sesi dokumentasi apakah sudah siap? Belum ya? Mungkin
Mungkin bisa merapat, Bapak Ibu.
Oke. Let me lead the documentation session. Izinkan saya untuk 1, 2, 3. Sekali lagi 1, 2, 3. Mungkin gaya cakrawala ya Bapak Ibu. Cakrawala. 1 C. Ya, 1, 2, 3. Last one. 1, 2, 3. Terima kasih banyak. Thank you so much.
Thank you so much for all participants.
Thank you so much for Professor Grootenboer and Professor Susiswo. May have your seat back. Thank you so much for the attendance too. Well, ladies and gentlemen, before we start the plenary session, we will have a coffee break until 10:25 a.m. For all on-site participants, please enjoy the drinks provided by our committee at site. Thank you. Bapak dan Ibu partisipan daripada ICoMathApp, sebelum kita lanjut kepada sesi selanjutnya, kita akan melaksanakan coffee break sampai pukul 10.25 waktu Indonesia Barat. Untuk Bapak dan Ibu yang bergerak ataupun yang hadir offline, tolong enjoy daripada coffee break yang sudah disediakan oleh panitia di luar. Monggo Bapak Ibu. Dan jangan lupa kita akan kembali pada pukul 10.25 waktu Indonesia Barat. And don't forget, 10:25 AM, please rejoin this
conference.
Yeah. Okay.
Thank you. Thank you. And now, my moderator. Oh.
You take the photo or me? Me aja. Okay.
Otherwise, I can.
Yeah.
I look bad. Thank you.
Thank you so much.
Thank you.
Hi, thank you.
Yeah. One. Yep. Yep. One. Was a bit hard to have pictures of scenery.
Oh ya, nanti dibuka.
also aboard flight VJ22 bound for Vietnam.
Iya, melaku dari warna-warni itu. Diangkat. Jual ya. Saya itu masih di rumah berarti, belum ke pasar berarti. Tak tahu deh, Pak. Seluler kali ya.
Halo. Halo, ini saya Budi. Saya di remove, bisa di ini nggak? Saya minta ID-nya nggak?
Selamat siang, Pak.
Ya, ini saya Budi, tadi saya udah login.
Iya.
Pakai ID ini saya tablet, kebetulan nama saya Start 335, itu nama kuliah aktuaria saya. Terus karena satu lain hal, saya di-remove dari itunya.
Oh, baiklah.
Ya, boleh minta ID-nya saya atau gimana?
Ya, baik-baik,
Nah,
saya
ini,
kirim ya, Pak.
ya, saya nggak bisa ikut di tablet saya.
Iya, baik, Pak. Halo, Pak. Ya. Halo, Pak. Bisa suara saya terdengar? Kami tidak mendengar suara Bapak.
Kalau di sini kedengaran?
Sudah masuk suaranya.
Ya, cuman saya nggak bisa share screen di sini. Jadi saya coba pakai apa namanya? Desktop saya buat presentasi, tapi yang suara pakai HP saya.
Oh ya, baik Pak. Kalau untuk share screen-nya bisa ya Pak?
Share screen, saya nggak bisa deh. Host disable participant screen sharing, saya nggak
Ya.
bisa.
Baik. Sudah bisa Pak?
Ntar saya cek lagi. Mana Zoom saya? Mana dia? This will stop others. Yes. Kok jadi itu tadi ada. Oh, saya lagi running ini simulasi. Mungkin karena low memory kali di desktop saya. Ini nih. Ini berarti udah lihat nggak di screen saya?
Belum muncul Pak.
Belum muncul ya?
Iya.
Tunggu. Ini?
Ya sudah Pak, sudah muncul.
Oke, ya. Oke. Jadi saya udah ikut gabung tadi pas Indonesia Raya.
Oh iya Pak.
Ya, terus tahu saya di remove. Anyway.
Iya. Iya mohon maaf Pak, tadi mungkin dari nama Zoom-nya.
Iya, itu nama kuliah saya itu. Nama kuliah aktoria.
Ya, baik. Mohon maaf Pak.
Iya, oke, nggak apa-apa. Halo, apa kabar semuanya?
Kabar
Siapa
baik Pak.
yang bisa lihat saya siapa nih? Pak dekannya ada. Siapa nama Pak
Iya,
dekan?
kami panitia Pak.
Oke. Ini panitia semua di sini.
Ada yang partisipan, ada yang panitia.
Oke. Azizah, yang mana ini? Yang waktu saya presentasi di ITS ya?
Iya betul Pak, yang Levi proses.
Oh ya. Jam berapa sih? Setengah 10 menit lagi ya?
5 menit lagi Pak.
5 menit lagi. Oke. Bisa lihat kan screen saya kan?
Iya, sudah tampil
Oke,
screen-nya.
ya, sip. Ya paling kayak gini. Jadi wajah saya kelihatan di situ juga. Paling di mozaiknya ya.
Iya, betul.
Oke, nggak apa-apa. Banyak yang datang on-site.
On-site ini 30 begitu. Halo Pak,
Ya,
apakah bisa di stop share terlebih dahulu karena kami mau menampilkan CV Pak Budi.
gitu. Kalau Bu Aziza aja bisa nggak host? Nanti izin balik lagi ke sini. Saya nggak tahu ini, nggak tahu. Oh ini saya free sekali. Stop share, oke. Udah.
Iya, baik Pak. Nanti jika Bapak kesulitan untuk share screen, kami bantu untuk share screen materinya.
Baik, makasih. Tapi saya coba di sini dulu ya.
Ya, baik.
Ya.
Baik, Bapak Ibu sekalian, kita akan memasuki agenda selanjutnya untuk Bapak Ibu yang masih berada di luar ruangan untuk segera memasuki ruangan. Terima kasih. Welcome, presenter and participants. We are about to start the plenary session right after this. Today we are having 3 plenary sessions with 3 keynote speakers from 3 different countries. For the first, Dr. Budi Arta Surya from Victoria University of Wellington, New Zealand. Professor Peter Grootenboer from Griffith University, Australia. And the last, Professor Dr. Bhakti S. Onggo from Southampton University, United Kingdom. Next, to start the marathon of a 2-day seminar, we would like to invite our first moderator, Mrs. Aziza SPD MSI, as the moderator of our first keynote speaker, Dr. Budi Arta Surya. Mrs. Aziza, the time is yours.
Thank you, Rama and Sefira. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Good morning to all participants here in Indonesia and good afternoon to Dr. Budi Arta Surya, His Excellency the Dean of the Faculty of Mathematics and Natural Sciences, Universitas Negeri Malang, Professor Dr. Hadi Suwono, MSI and staff, the Honorable the Head of the Department of Mathematics, Mr. Latiful Anwar, MSc, PhD and staff, the Honorable Chairman of the ICoMathApp 2023, Mrs. Jamaliatul Badriah, PhD, the Honorable Speaker, Dr. Budi Arta Surya, and Honorable presenters and participants. Welcome to the 4th International Conference on Mathematics and its Application 2023, and welcome to our first plenary session. First of all, I would like to introduce myself. My name is Aziza. I'm from Department of Mathematics, Universitas Negeri Malang, and in this session, I will be serving as your moderator. Today, you will be hearing a presentation from Dr. Budi Arta Surya about statistical inference for incomplete data. But before we get started, please let me read a brief biography of our distinguished speaker today. Dr. Budi Arta Surya currently is a senior lecturer from Victoria University of Wellington, New Zealand. He graduated with cum laude from Institut Teknologi Bandung in 1997 for bachelor's degree. Then he got master's degree from University of Twente, Netherlands, and got PhD degree from University Utrecht, Netherlands. His research interests are and then and some of his journal edit and some of his research interests are next. And here are some of his publications. And next, here are some of his journal editorial activities. Ladies and gentlemen, before the presentation begins, I would like to tell you the regulation on how the presentation will be conducted. First, I would like to give the time to Dr. Budi Arta Surya to present the material for about 45 minutes, and there will be about 15 minutes for the Q&A session. During the presentation, if anyone in Zoom meeting has questions or comments to Dr. Budi, please write them down in the Zoom chat room. For attendance here in this room, you may speak also directly to Dr. Budi during the Q&A session. Without further ado, please now allow me to welcome Dr. Budi Arta Surya, who will be speaking to us about statistical inference for incomplete data and introduction with application. Dr. Budi, the floor is yours.
Okay, thank you everyone. Hope you're all doing well. So first of all, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, and may God be pleased upon you. So first of all, I'd like to thank the committee for giving me a chance and the invitation to present my work. So to all of you, and also especially to the dean and also the head of the school for the invitations. So so this afternoon, I'm going to present one of my recent joint work with Professor Helena Friedman from New York University in the US. Whom I visited before the COVID. So the title of my talk will be Statistical Inference for Incomplete Data. And this is just a brief introduction, and then I will discuss some applications, which is based on my joint work with Professor Friedman of NYU. So this is my email address. So feel free to email me should you have any questions or to follow. Okay, so this is the outline of my talk today. I will briefly discuss about data, how you define data from the viewpoint of statistics, and then also the expectations maximization EM algorithm, and then I will move. And I will discuss about estimation in a general mixture. Okay, give me a minute. My cell phone is running low. Okay, so where were we? So this is estimation in general mixture of microgram process. So this is the main topic of my presentation today. And then also discuss about how we estimate the mixture using the EM algorithm. And I will conclude the presentation with some numerical examples. Okay, so this data. Now, from mathematically point of view, so we define data as a vector. So a vector of dimension p. So the value of the vector is real. So this is real value vector of dimension p, which could only be partially observed through a vector y, which is again real value. But the only thing here, the size of the observations is less than the dimension of the original vector x. Now, so they are typically random. So x and y are typically random. And then here now we're talking about random vectors. So random variables, so which are probabilistic object defined on the same probability space. So two random variables x and y are defined on the same probability space. the triplet omega, the sample space, filtrations, and the probability measure on which events on the filtrations are measured. Okay, and then we denote here the measurable space X and S. So this is the measurable space for the original factor X, and then Y and T. This is for a measurable space for the observations vector Y. Now, so here, as I mentioned earlier on, that the original factor X is only partially observed. So to give you a motivation here, okay, we'll discuss about this later on. So here, the way we describe the partial observations of the factor X is through the mapping. So we assume there exists a function or a mapping T, which maps any element in the sample space X to a sample space Y. And then also we assume that there exists probability density functions. FC, this is density function for the factor X, and then also F naught FO of Y. So this is density functions for the observation factor Y. So and then also theta describe the law of the original data X. Yeah. So this is quite abstract at this stage, but I will give some concrete examples shortly. So because of the partial observations of the original factor X, so we define what do you call it? We define a set which comprises a subset of X, for which every element of the X in that set corresponds to the observations Y. So the Y, so for a given Y, so we want to find which X in the original sample space X that's the observed data Y corresponds to. Okay, so now it follows from this is classical work, Helmholtz and Savage. Basically, this is from basic rule of probability that you can think of Y as the marginal, the distributions of Y is as a marginal distributions of X. Yeah, because the X contains more information than the Y. So you can think of the PDF, the marginal, PDF probability density functions of the observations is just a marginal functions of the PDF of X. Okay, why? Can you still hear me? Because I got an yeah.
Yes.
All right.
Yes.
Okay, so yeah, so equation 1. You can also see the slide, by the way, right? Yeah. Yes. The
Yes.
slide is yeah. Yeah. So the equation 1 is nothing but the marginal distributions of the PDF of X. Now, so the point here, can we somehow, so theta, keep in mind, theta is the parameter of the PDF, the density functions of your factor X, the original data. Now, so we want to estimate those parameters using the available informations Y. So this is equation Y here. So by taking the likelihood, so here equation 1 tells us about the likelihood functions of the observations. Now by taking the log of equation 1, and then we get the log likelihood of the observations. Now as you can see, the log likelihood functions is slightly complex. Okay, and then it's difficult to single out, to pull out an estimate for parameter theta by taking these by deriving these core functions. So this is basically derivative of the log likelihood of the observed data y, and equalize to 0. And then this is a system of, and then now we are looking at solving system of nonlinear equations, which is complex. In special case, we might be there might be an explicit solution to theta out of these equations, but in general we cannot. So we need to estimate theta recursively using EM algorithm, so expectations maximization algorithm. So this algorithm was had been around prior to 1977. This is a topic on its own, but but starting from the paper of Dempster in 1977, the EM algorithms has revolutionized the statistical inference for incomplete data. Now, how does it work? The algorithm. So the algorithm basically goes as follows. So again, here YK is the samples, the observations. Okay, so we have n samples of observations, and then we assume they are independent. Okay, so and then here, and then theta hat L is the estimate of theta at the iteration. So we want to estimate the parameter theta recursively. So at the step L of the iterations, if we want to project, so keep in mind the conditional expectation here of the log likelihood. Conditional expectation is nothing but the projections. If you can think of this is like a projection in a Hilbert space, where the norm is equipped by conditional expectations. Yeah, so you can think of the conditional expectations appearing in the equation 2 as the projections. So projection is basically you want to extract some informations regarding the log. If you can see the one inside the expectation, the log of the likelihood, log likelihood of the complete data. So keep in mind your X is your complete data, whereas your Y is incomplete data. Now, so you can think of the log likelihood of complete informations as a vector. Yeah. So and then you want to project this vector onto space spanned by your observations Y. So this is basically you want to extract something from limited resources, and then because of your observations are assumed to be independent, and then you take the average. So the maximum, so the update at the iteration L+1 of the parameter theta is chosen in such a way that this average, the average of the conditional expectations here is maximized. So this is so again. So there are implicitly from what I just described, the equation 2 here, there are two steps embedded in the algorithm 2. One, the E step. So the E step is taking the conditional expectation of the log, yeah, conditional expectation of the log likelihood of complete data given the observations. So this is the E step. We need to evaluate these conditional expectations, and the second step is to maximize this. Yeah, so to maximize the average of the conditional expectations. To find the update. So there are two. So the EM algorithm comes into two steps. Yeah, the E steps and then the M steps. Now I got some results, but I need to do some revisions on how you can improve this for bootstrapping. But this is not what I'm going to discuss. For example, now for the just to motivate the application of EM algorithm. I will discuss this for the algorithm on my recent work. So as I said, mentioned earlier on, so this is based on a joint work, excuse me, with Halina Friedman. So Professor Halina Friedman from New York University, School of Business, the Department of Statistics of the Business School of the NYU. Okay, so this is the title, as you can read there. This is estimations in a general mixture of Markov jump processes, and this is available in the archive. So we have completed the revisions and submitted back to the journal. So we submitted to Canadian Journal of Statistics. Hopefully, will appear soon, inshallah. Okay. Now, what is this? Now, so we know Markov jump process. So Markov jump process is a process that can be used to describe sequence of events. So these events might correspond to health propagations of a patient. Let's say a patient is getting help, is in healthy conditions, and getting sick, and then the sickness getting worse, and eventually the patient dies. This is also we can model it. We can use the Markov chains to model to model the credit rating. So corporate bond, like obligasi in Indonesian, like obligasi. If the obligations, the bond is issued by corporate corporations, it comes with the credit rating. And so many things. So this is here. Let me see. Yeah. So Markov process here has been used in finance. Yeah, so to model the credit rating, the transition of credit rating for corporate bonds. Actuarial science, I'm also, this is one of my active field of research as well. So this is how you model the joint lifetime of a patient, or you can also price a product, pricing insurance product using the Markov process for the option pricing, queuing theory, and so on. Yeah. Now, so the Markov process is uniquely characterized by the intensity matrix. So here we think of the process as observing state. So what is observing state is the state to which once the process move into, they never come back. Okay, never move out of the observing state. So as you can see, the Markov process is uniquely characterized by intensity matrix. So this is a matrix whose rows sums to 0, and the diagonal element is negative. Okay, and the diagonal element is positive. So this is Markov processes. As you can see, people have been doing this in the field I mentioned before, also in marketing. But there is how do you call it? There is a need to improve Markov process, namely because of due to the time homogeneity and also the stationarity property of the process. Namely, by stationarity, meaning that what matters is the durations. Okay, the probability of moving from one state to another is only determined by the durations. The time elapsed between the two states, and also the future development of the process is only affected by the current state, but not the past observations. And this is and one that's two things, and the other thing is so the most applications in this slide here are based on the assumption that the subjects of study, whether the bonds, the patients, and so on, are homogeneous. Yeah, homogeneous meaning that one model fit them all. Yeah, so one model for all. So this is not in reality. We can subjects are heterogeneous. So meaning that some people have the ability to recover at earlier, at higher rates of recovery, and some other with the low rates of recovery and so on. So in order to capture this heterogeneity in the subjects, we cannot use the Markov process for the reason I just explained to you. So we come up with the mixture. So we mix how do you call it, certain number of Markov jump processes with the different intensity metrics. Okay, keep in mind each Markov process is uniquely determined specified by the intensity metrics, and others also intensity metrics. Now, so for the mixture, we just mix a process. So this is different here. In statistics, there have been there has been a lots of efforts devoted to studying a mixture of distributions. Okay, the mixture of distributions. Now this is slightly different. So what we consider here is a mixture of process. Okay, so mixture of process does not necessarily lead to a mixture of distributions. Now, whereas a mixture of distributions or the law of the underlying Markov process here does not only leads to a special mixture of the process. So you see, so the mixture of process is more general than a mixture of the underlying law of the Markov process. And also, the good thing about the mixture is that even though the underlying Markov processes are Markov, the underlying processes are Markov, the mixture itself are not. Okay, so this is so being so this is the merit or the main appealing feature of the mixture of Markov process, which is due to the time homogeneity. Okay, the process is no longer time homogeneous. So meaning that the transition from one state to another, it depends on the current state, the current time. So it's basically the age, and also it depends on the past history. Okay, the past observation also determine the future development of the process itself. So it's just not Markov, and it's a very nice mixture. So the idea of mixture, the mixture itself went back to in 1995. So it was first introduced by sociologists from US. This is, they call it mover-stayer model. For those who study statistics or sociology, so the mover-stayer model are very well known. Okay, so this is a mixture of two Markov chains, Markov process in discrete times. Okay, so this is the mixture here is used to describe how the tendency of a labor, how fast or how frequent a labor, or how do you call it, laborers change their work. Let's say someone work at this particular place, and then they move around. Okay, they move their job. Or some other stay or remain in the same job. Okay, so there are two types of cohort there. So one cohort tends to move around, change the job, whereas the other one tends to remain in the same job. Yeah. So in 1995, and then Friedman, Friedman, the same person, Halina Friedman, in 2005, extend extend the mover-stayer model. So instead of considering for mover style model, it's a mixture of two Markov chains, one moving, one staying, so it doesn't move at all. Now, so in 2005, Friedman extend the idea, generalize the idea by looking at the mixture, the mover style model in continuous time, and also allowing the mixture, allowing the mixture of two continuous time Markov chains of different with a particular form of intensity matrix. Okay, and then in 2008, Friedman introduced Schurman applied this for credit rating. So those two papers appear in a very top journal. And then I came up with I identify the idea that's why. So because of the mixture introduced by Friedman in 2005 was a particular type of mixture, and then I wrote her email saying that, well, actually we can generalize this. And also the paper did not discuss an estimation of standard error for the estimation. So there are lots of things missing in that paper. So I come up with this idea. Okay, so this is the results of this. We come up with the paper I just mentioned to you. So so this is more or less about the mixture. So the mixture, the statistics for the observation here is determined by this is statistic, the question 6. So the so BI is the indicator, is Bernoulli random variable, which has value 1 whenever a process starts in the state I. So the Nij is the number of transitions between states I and J. So what is it then? Ni is the number of transitions out of the state I, and Zi is the total amount of times the process occupies in the state I. So here, these are the statistics for Markov process. Now for the mixture, we have this the pi. So the pi here tells us about the which mixture. Now let me say, I forgot to say that. So there is hidden information here. So what are the incomplete observation here? So once under the mixture model, once we observe the process, we cannot really tell from which group the observed process came from. So let's say we have two groups of one moving with the intensity Q1 and the other one moving with respect to intensity Q2. Now, when we observe the process, we cannot really tell from which group the observed process came from. Okay, so this is to say, when we observe a patient, we cannot really tell from which group the patient came from. So there is hidden information there. Yeah, so you cannot tell this from the observation, from your data. Okay, so this is to estimate the parameter. So we need to so we need to derive the likelihood function of the complete informations. Okay, so this is how. So this is the slide. Now, also let me tell here something about censoring. So censoring here, when you observe a process in this certain state, because our observations are periodic, we do not observe the process continuously. So and then this observation might subject to right censoring. So this is to say, you may not observe the process completely. When you observe the process in the certain state, you do not observe the process completely. Okay, because your times, you have a fixed observation time. Now, so this is under so the tau is your observations, and the likelihood functions is for the non-sensor observations. So this is given by this expression here. So this is the likelihood. So this is basically here it follows on the this is for the Markov process. Okay, now for the mixture, we need to think of for the mixture, this is the log likelihood function for the mixture. Okay, so we recall, observe or notice the new indicator variable pi there, sitting there, and also this parameter here, SIM. So SIM is the probability whether or not the process observed in the state I comes from a group M, okay, cohort M. So a little bit of probability theory going on in here. So at the background, so this is probability. This is my field. So my field, since my PhD or master degree, master study is the probability theory and stochastic process. So this is my my expertise. But I recently moved into statistics because probability in statistics, stochastic process are the basic foundations of statistics. All right, so this is here. You need to estimate the parameter pi and then Tij for each mixture. Okay, for each mixture, and then and this is using basic optimizations you can estimate here. So basically you take the log. So take derivative of the log likelihood and equals to 0, and then you should be able to derive an estimate of the pi I. So pi I is the probability of finding the process in the state I at time 0, and the Tijm is the intensity matrix of the underlying Markov process XM. So it is given by the ratio of the number of transitions, Ij transitions, divided by the number of total time the process occupies in the state I, and this is the observing state, the delta, and the SIM is the switching probability. So the probability which gives, which tells in which group the observed process came from. Yeah, and then this is we define some statistics. It is in there. So NIJM is basically the number of transitions, I to J transitions that corresponds to the underlying Markov process XM. Yeah, the mixture M. Okay, so this is observed visual information matrix. So as you can see, the observed visual information matrix is nothing but the minus Hessian matrix. Okay, the minus second derivative or the log likelihood of the observed, the minus second derivative of the log likelihood of the incomplete observations. Okay, this is given here. This is quite complicated, but it just takes some computation to get this. We have a formula, by the way, for the. No, I did not present it here. So these are the element of the information matrix. Which is written in terms of some factor here. Okay, some statistics which are basically defined here. So the C hat, P hat, and so on. And as you can see here, in order to implement this, there are lots of computations going on in practice, because you need to count the number of transition between states, the total times the process occupies in each state, and so on and so forth. And then you need to derive every element of the transition matrix, and the matrix itself is quite large. So lots of things going on. So in terms of, yeah, so this is the E step. For the E step, in order to update the iterations, we need to solve the sorry, this is the E step. Remember, so you need to calculate the conditional expectation of the log of the complete data log likelihood. Okay, given the observations. So you need this observations statistics in the E step. And what is the N in the M step? This is the M step. Yeah. So the M step you just replace here. Yeah. So this is in the M step of the algorithm. We get an explicit update. Okay, for the iterations. Okay. So this is pi hat here. It tells you an estimate of the parameter of pi. So this is basically the probability of how likely the observed process belongs to the group M. Okay. So using the statistic, as you can see, this is quite lengthy. Also, and this is the M step, as you can, as I mentioned before. So it's just pretty much like the results for the MLE, maximum likelihood estimate for the complete data. But the only thing you just replace it by those obtained from the M step. Yeah, and then you run the iterations until stopping criterion here, convergence criterion is met. So this is basically the Euclidean norm of two consecutive estimates is less than 0. So this is for given epsilon. Now, this is the examples. This is just to show the consistency. I did not discuss here about the consistency of the estimate, but in the paper, yes, we give a proof for the consistency of your estimate, because this is the important things. We want to make sure that our estimate converts to the true value. Okay, so we need to prove that, and then the proof is given in the paper, and also the what do you call it? The large sample property of the estimate. So, like the estimate is a random variable, and it must it satisfies the normality condition under CLT. Okay, please refer to the paper for more details of the proof. Now, this is here. We consider a mixture of two mixture with three states, transient states, and one observing states. And this is the three. So three mixture. We have three components of mixture. Q1 is given there. Q2, this is intensity matrix for second component, and Q3 is the intensity matrix for the third component of the mixture. And as you can see, the parameters here, there are 24 parameters of the mixture. This is quite lengthy. And the true value is given here at the second column. And then this is shows the consistency. Yeah, so this is the bias. As you can see here, K is the number of samples. Okay, 750, 1,500, and 3,000. And as you can see, in the absolute value, bias decrease as we increase the sample size, and also the root mean square error. So the root mean square error also decrease. So as you can see, so this is consistency for the estimator. Now, what is the estimate? Yeah, so this is shows us about the consistency of the estimate. Now, this is the MLE, the estimate of the parameter. The true value is given given in the second column, and the estimate in the third column. As you can see there, the estimate is very close. Yeah, for P. So P is the probability of switching probability. That's that tells that gives the likelihood of finding the observed process in the cohort. Yeah, so as you can see, it's very close, 0.5 compared to 0.4998 for the estimate, and so on. This is very close there, yeah, to the true value. Yeah, so it takes time to figure out here to implement for these implementations. I use R for the computations. as you can see here, the parameter, there are 24 parameters. So the matrix is quite large, 24 by 24. And this is this is root mean square error. So the standard error. So the difference between the true value and the estimate, as you can see. So this is RMSE from the sample. Yeah, this is from your sample. And this is here, the last column is the one from our theoretical value, using the Hessian matrix, the Fisher information matrix for the mixture. And you can see again, this is very close. This is very close to the true value. The RMSE and the true value are very close, even equal for some parameter. So as you can see, we are very happy with this result. So this is shows that so the theory, the results are correct. Are confirmed by numerical simulations here, because we need the information matrix, because because in an exact, we get an exact estimate for that. All right, so here this is because of the for the mixture there is a hidden information, meaning that we do not know from which group the observed process come from. Now we need to test the identifiability issue. Okay, so this is to say what I did here. So I generated two mixture. So we consider a mixture of two Markov processes, and then pretending not knowing the number of mixture, and then we try to estimate the parameter of the mixture by starting with the Markov. So we assume that the generated process, the mixture, come from one process. So meaning that there is no mixture. So it's a Markov. So and then we calculate the AIC. Actually, this is BIC. In the revisions, we also calculated the BIC. So we compare it. So and then we also, this is for Markov, and then we also try to fit the observations using two mixture. Regime correspond to mixture. So and then we calculate the AIC and also 3 mixture, 4 mixture, and so on. And as you can see here, so the AIC has the lowest value for the 2 mixture. So this you can see. It confirms by the so the null hypothesis is accepted. So meaning that we started with the 2 mixture, and the test confirms that the observations come from a 2 mixture. Now I also consider 3 mixtures, mixture of Markov, 3 mixture of Markov processes, and the same thing, So we try to fit the parameter of the mixture using Markov. So by assuming there is no mixture, it's only one populations as a whole, the observations, and then also we test that that the actual observations come from 2 mixture, and 3 mixture, 4 mixture, 5 mixture, and 6 mixture, and so on. And then we calculated the AIC, Akaike information criterion, and then and see the lowest value. The smallest value of AIC corresponds to 3 regime. So the null hypothesis is again accepted. So here, so AIC tends to give you the correct, tend to specify the right number of mixture, whereas the BIC tends to, I did not present here, tends to select the simple mixture. So which is, which tend to reject the null hypothesis. So this is what our research finding also. Now, so to summarize my talk here, yeah, by the way, we apply also the theory to FEN ICU dataset. So this is for ventilations, when someone for a patient goes to emergency, so there are 2 possibilities, whether the the patient needs ventilator, need to ventilator or do not need a ventilator. So we have data sets. This is medical data sets, and we apply the theory to this data sets. And as we can see, for our conclusion that the mixture model plays more significant role compared to the Markov model, and it's thanks to the heterogeneity of the mixture, which absent in the Markov model, and also mostly presents in the data sets. Also we have some more. We can retrieve valuable information regarding hidden information in the sample. Also, the flexibility. Now, this is also flexibility and availability. So, because we have a closed form formula, so when it comes to estimations, it is very fast. And out of this paper, I have another 2 papers that gives the law or the distribution of the lifetime. So this is the patient, like patients, the lifetime of patients, until and then I derive a new multivariate distributions. So this is conditional multivariate distributions of a phase type. This is something I will share, discuss with you in other occasions. Okay, so thank you very much for your time and for your attentions. And you have any questions, please feel free to ask, and I'll be happy to take them now. Thank you.
Okay. Thank you very much, Dr. Budi Arta Surya, for giving such an informative and interesting presentation. Ladies and gentlemen, now we come to the question and answer session. First, I will give the chance to participants in this room. You may ask directly to Dr. Budi. Please raise your hand, and I will give the time to you to speak directly to Dr. Budi. And please don't forget to mention your name and also your affiliation. Okay, we have 2 questions, I think, here.
Yeah.
Please, first.
Yeah, feel free, ask me questions.
Okay.
The lecturer or students, potential students, is also
First
welcome.
Lecturer, yeah. I think, Pak. Okay.
Okay, thank you very much, Mr. Budi. My name is Dania. I am from Department of Mathematics, Universitas Negeri Malang.
Okay.
My question is,
apa kabarnya? Yeah.
From the explanation given, I coached that from incomplete data. For incomplete data, there are 2 methods: expectation maximization and general mixture of Markov jump process. Based on your research you have done, can you suggest a topic application where the EM algorithm and general mixture of Markov jump process is used, especially in actuarial science? And the second one is, can the EM algorithm be compared with other optimization technique in parameter estimation? Thank you.
Oke, terima kasih. Dengan Bu siapa tadi? Bu Lama ya?
Dania, Pak.
Dania, sorry. Yeah. Okay, terima kasih. Thank you for the questions. So yeah, you can. This model is relatively new. I'm not trying to be exaggerated, but to my understanding, this is a new model. You can also. Can you see my screen?
Yes.
Slide Budi Surya.
Still the same slide?
The same slide. Sorry. I'm trying to go back to my website. So this is I'm trying to what is it? Okay, yeah. So you share. What is it? Nope. Ini saya lagi, I'm running a program in my, okay. What can you see from from the screen?
Still the same slide.
Still the same slide. Yeah, you can actually apply the mixture using one of my paper here. Okay, hang on. So we can apply, for instance, mixture for modeling the lifetime of a patient. Okay, and also for the pricing. For the pricing, I'm trying to where's my slide? I want to share screen. Okay. Okay, so this is well, trying to get my screen. So we can model the not this mixture, but for the actual science, we mostly model the lifetime. Okay, the time until a patient and a subject exit. So exit by death or exit by other than death or by sensory. So this is the time until the time to event. So this is also the lifetime. It's also random. Okay, so let's say a patient is currently in healthy conditions and then they die. So the lifetime, the remaining lifetime is also random, or like a bone. You know, the bone is also the lifetime of a bone is also random. Now, the thing here, we want to model the joint distribution of the lifetime of the subject. And then for that reasons, we can, the current model is so-called phase type distributions. So phase type distribution is distribution of the lifetime of a Markov process. Now, I was going to show you my paper. If you look at my website, look at my paper in a conditional multivariate distribution of phase type under the finite mixture of Markov jump processes. If you look at this paper, yes, this paper here. Okay, so this paper you can so you can model the lifetime of a patient. You know, so this is multivariate distribution. Can you see that?
Yes.
Yeah. So okay. So this one here. So this is the lifetime here. So this is the joint distribution of the lifetimes of a patient. Now you can use the. So this is again a mixture. Okay, so this is a multi-resolution mixture of Markov process. As you can see, the distributions are different from the Markov. If you compare it to Markov here, have a look, you know, at this paper. So it's basically, so you can the joint distribution can be used for pricing. Okay, if you know. If you want to know, if you know the law of the time to event, then you can do the pricing. Okay, like you can calculate if we want to price a certain product. You want to know, you need to know what is the distribution of the lifetimes. Now, by taking into account the heterogeneity in the subject or like in the bone, this is the good thing about the mixture process. I have also current work with a colleague from University of Queensland. So University of Queensland. Can you see the screen? This is, if we go back to the
Okay.
Yeah, so this is the, you can also for the parameter, or for the estimation parameter, you can also beside the EM algorithm, what else you can use? I don't know whether you can use the artificial intelligence and all that to estimate the parameter of mixture. So this could be something else you can think of for future research. Yeah, hope I hope I answer your questions.
Yeah. Okay. Miss Dania, is there any comment or feedback?
Okay, thank you, Pak Budi, for your answer.
Yeah.
Okay.
Makasih.
Okay, we go to the next participant who want to speak directly to Dr. Budi.
Yeah.
Okay, thank you so much, Mr. Budi, for the representative material. I am Lita Wulandari from Universitas Negeri Malang, and Mr. Budi has written an article about some results on maximum likelihood from incomplete data, finite sample properties, and improve an estimator for resampling, and has explained equation 2 and then YK about the sample of observation, and then estimate the theta L and log likelihood of the complete SF vector and so on. And then I want to ask, is there any way other than an estimator to improve estimation in repeated sample application? Because it's interesting for my subjects at actuarial science. Thank you so much.
Okay, thank you for the questions. So for the you can, so that paper concerns with estimation. No, actually, that paper is concerned with finding a way to improve the estimations. It's basically we want to improve the result of the estimations using resampling. So it's basically bootstrap by in the way that the standard error is minimized, is smaller than using the EM algorithm. So this is I presented in that paper, still subject to revisions, by the way. This is that is for improving the estimations for the mixture using repeated samples. Whereas what I presented in my talk, we do not use resampling. Okay, so we use the sample once, whereas when is the incomplete data? The incomplete data can be used and is handled with the method you can mention. Yeah. So so in that paper, I discussed about how we improve the estimations using resampling technique. Okay, like a bootstrap. Now, hoping that the standard error is smaller, and also the confidence interval is also smaller, because this is the idea, right? So we want to increase the accuracy of the estimations by in such a way that the standard error becomes smaller, and also enhance the confidence. 95% confidence interval is smaller because the standard error is getting smaller. Okay, so when is the incomplete data cannot be improved? Complete data cannot be improved. it cannot be used for research. What do you mean by when is the incomplete data cannot be improved, therefore it cannot be used for research? What do you mean? Can you clarify this?
Okay, the last question for chat room.
Yeah.
Excuse me, Pak, the last question or the question in the chat room?
Oh, the last question. Yeah. So
The
here
last
you said that when is the incomplete data cannot be improved. So what do you mean by
Ms. Rita,
incomplete?
would you like to repeat the question maybe because Pak Budi is still confused about increasing.
Cannot be used for research. Yeah. So that paper basically, yeah. So that paper, you know, is giving a way to improve the estimation for the mixture. So yeah.
Okay. The next question from the chat room, Dr. Budi, this is a new topic from Ibu Jamaliatul Badri.
Oh yeah, so this is what I was reading. So yeah,
This is a
sorry,
new
I thought this
topic
is.
for me.
Yeah. Therefore, I want to know when is the incomplete data can be used. Mentioned there will be the methods you mentioned. Then it cannot be improved or it cannot be used for. The incomplete data issue talk is similar with missing. Yeah, so it is basically is similar to missing data. You know, so you don't know. So this is incomplete data, meaning that we do not have complete informations about the subject of the study. Whereas the missing data, here you might have, you have a missing data. So here we do not have a missing data. What I meant here, incomplete is the information is not complete. We do not know from which cohort the observation came from. So we do not have the missing data. So for missing data, I do not know. Probably you can also use the EM algorithm. So I haven't looked at it yet for the mixture. So let's say, you know, when you observe the process intermittently, you know, at a discrete point, probably is more relevant to this question. Now, let's say if you observe the process continuously. Now, what I presented in my talk, we assume that the process is observed continuously. Okay, I did not say that, but from the presentation of the result, the mathematics assume that the sample paths are observed continuously. Now, when the sample paths are not observed continuously, then we have missing data. Yes, so we have missing information there. Now, there is a way to handle this. Then this is, if you look at my slide, my website, I gave a talk at NYU, New York University, and Rensselaer Polytechnic Institute, and also in New York, about how you estimate the mixture using incomplete data. Again, incomplete information. So meaning you only observe the process intermittently, you know, periodically, not continuously. So this is what I understand about the incomplete information. About the missing data, I haven't looked at it yet, so I don't know whether I answer your questions.
Okay.
Any other question?
Question, yeah, in chat room.
Can each case be? Question: can each case be immediately known? That is, it is a mixture of process. So here, for the mixture process. Now let's say, so we cannot. We do not know immediately. We cannot immediately know conclude from which component or cohort or group the observed process come from. Now let's say, how can you say this? no, you cannot infer it, the group. So this is to say, let's say you have two populations, okay, two populations, the same age, the same gender, the same race or whatever, but one with a good immune system, one with a weak immune system. You know, you cannot tell them which one, you know, from their body appearance, they are in healthy condition, but the immune system are different. You know, so this is like you close your eyes while you receive them. Can you tell which one is which? No, you cannot tell them. Even you finish the observations. Okay, now if you, so this is the things, because the latent nature of the mixture, you cannot separate the subjects of your study. Otherwise, you know, it's no longer a mixture. So Markov process is a special kind of a mixture. If someone, okay, let me say one process, okay, you consider two processes, one moving forward and one moving backward. Then this is not a mixture. If we mix them, this is not a mixture, because yes, in this case, if you mix two process, one moving forward and the other one moving backward, then the mixture is a Markov, meaning that when you observe the process, you can tell which one is which, because from, you know, one when you observe the process moving forward, then you know, oh, this process from group one. If you observe the process moving backward, then you know this process from the other group. So as a result, the mixture is a Markov, because you can identify the group. So whereas for the mixture, they do not. Does that make sense?
Yeah.
Yeah.
Okay.
Yeah, if you want to have any students or a lecturer who wants to do PhD, I'm happy to welcome here. I have a PhD student doing. I will try. Yeah, I can help with your PhD, either in statistics, because I just recently moved to statistics because I like it. But this is mostly, yeah, or in actual science, really mathematical. You know, like optimal stopping, Levy process, whatever. So I currently have one PhD student from ITS, Institute Teknologi Surabaya, doing PhD in actual science with me. So this is very different from what I presented here. This is not statistics; it's more mathematics. You know, like so his topic is about pricing. Yeah, about how do you call it? Creating an insurance product. Yeah, so yeah, insurance product, or statistics, or probability. Okay, computational probability. So sorry, any other questions?
Okay, the time is limited. I think this is the last question for this session.
Yeah.
Okay. Ladies and gentlemen, unfortunately,
You're welcome.
Our time is limited, and we finally come to the end of the first plenary session of ICoMathApp 2023. But before we close this session, let me briefly summarize the main points from our speaker. First, in terms of statistical significance, the Markov mixture model outperforms the Markov model in explaining variability in the dataset. And the second, it might be used to model heterogeneity in the population object in terms of event rates. Ladies and gentlemen, we have had some lively and interesting discussion with our speaker today. I would like to say thank you again to Dr. Budi Arta Surya for your informative and interesting talk, and to audience here in this room and also in the Zoom meeting. thank you very much for your active participants. Hopefully the presentation will be beneficial for everyone. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam
Yuk,
warahmatullahi
sama-sama.
wabarakatuh. Thank you, Mrs.
Yeah.
Aziza. And ladies and gentlemen, once again, virtual clap and big applause for Dr. Budi Arta Surya. A very informative and interesting presentation. To
Makasih. Thank
express
you.
our thankfulness, we present Dr. Budi Arta with a token of esteem from our department. The hand offering will be done online via Zoom. To the operator, please do the duty.
Makasih. Thank you very much.
Well, ladies and gentlemen, in the spirit of united through knowledge, we extend our heartfelt thanks to Dr. Budi Arta Surya for his invaluable participation. May his endeavors continue to inspire us in the pursuit of mathematical excellence.
Inshallah.
Ladies and gentlemen, before we continue to the next agenda, to all participants, please fill out the attendance list in the link attached to our Zoom chat room.
Sebelum memasuki agenda selanjutnya, saya ingatkan kepada seluruh peserta untuk mengisi link presensi yang dibagikan di kolom chat Zoom.
Our next agenda is a break and lunch. We will start the second plenary session at 1 p.m. For all participants, please rejoin our conference at 1 p.m. Thank you.
Agenda selanjutnya adalah istirahat, sholat, makan. Kita akan melanjutkan agenda yang kedua pada pukul 1 waktu Indonesia Barat. Dan saya ingatkan kepada seluruh partisipan untuk bergabung kembali secara virtual dan offline pada pukul 1 waktu Indonesia Barat. Terima kasih.
Dan sampai jumpa di second plenary session. Monggo Bapak Ibu yang mungkin mau mengisi perutnya bisa ada di luar.
Iya, saya selesai.
berada di luar ruangan segera memasuki ruangan.
Sekali lagi kepada Bapak dan Ibu yang masih berada di luar ruang seminar, dimohon untuk segera masuk ke dalam ruangan karena agenda selanjutnya akan kita mulai.
Ladies and gentlemen, please come in the seminar room because the next agenda will be start.
Sekali lagi kepada Bapak dan Ibu, peserta dan juga panitia yang masih berada di luar ruangan seminar, supaya segera masuk ke dalam ruangan karena agenda selanjutnya, agenda yang sama-sama kita tunggu akan segera kita mulai.
Welcome, presenter and participants.
We're about to start the second plenary session right after this. And we would like to invite our second moderator, Mrs. Latifah Mustafa Lestianto, as the moderator of our second keynote speaker, Professor Peter Grootenboer. To Mrs. Latifah, the time is yours.
Okay, thank you Safira and Rama. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon to all participants. His Excellency, the Dean of Faculty of Mathematics and Natural Sciences of Universitas Negeri Malang, Professor Dr. Hadi Suwono, Master of Science and Staff, the Honorable the Head of Mathematics Department, Latiful Anwar, PhD and Staff, the Honorable Chairwoman of ICoMathApp 2023, Jamaliatur Badriah, PhD, the Honorable Speaker, Professor Peter Grootenboer, and distinguished presenters and participants. Welcome to the fourth of International Conference on Mathematics and its Application 2023, and welcome to our second plenary session. I am Latifah. It gives me a great pleasure to be the moderator for this plenary session. You'll be hearing a presentation from Professor Peter Grootenboer entitled, "What Does It Mean to Learn Mathematics?" First, I'd like to read a brief introduction to our distinguished speaker today. Professor Grootenboer is currently a professor of education at the Griffith Institute for Educational Research, Griffith University, Australia, and also an adjunct professor at the Faculty of Mathematics and Natural Sciences, Universitas Negeri Malang, Indonesia. His research focuses on 4 key interrelated areas, including practice and practice theory, mathematics education, action research, and leadership. He completed his master's degree and doctorate at Waikato University in New Zealand. And here are some of his publications. Before the presentation begins, let me tell you how this plenary will run. Firstly, Prof. Peter will present the material for about 45 minutes, and there will be about 15 minutes for the question and answer session. All participants can type the question in the chat room. And without further ado, now allow me to welcome Professor Peter Grootenboer, who will be speaking to us on what does it mean to learn mathematics. Professor Grootenboer, the floor is yours.
Thank you. Thank you.
Okay.
Thank you. Thank you for the invitation. Although I am a visitor from Australia, I'm also a member of this university. So I have an adjunct professorial position in this department. So I'm a visitor, but I'm also an insider. I also want to say how thankful I am to Professor Hadi Suwarno and Latiful and Latifa, who have looked after me since I've been here. I also want to apologize to Latiful that I'm wearing a t-shirt in the photo, because I now know that I should not wear a t-shirt. So I now have a proper shirt, and hopefully I look like a good Indonesian man. Also, tell me if I'm talking too fast and I will slow down, because sometimes I get excited. I also want to thank the two MCs. Thank you for coming. I'm very impressed that two students would come to a maths conference in the holiday, and also acknowledge Holly, because she hosted me last time I was here in 2019. So I want to talk about learning in mathematics. What does it mean to learn? And okay, now we haven't turned it on. Oh. Okay, thank you. And it's I gave a talk on Tuesday to the department, and this is not the same, but it's a bit related. So I want to start by looking back about what practice is and the theory of practice architectures, and then I want to look forward. Now, in looking forward, I'm not telling you something I know all the answers about. I'm telling you about something we're interested in, we're worried about, we're inquiring into, because we think there needs to be some different things done from what we've done in the past. So the reason we're taking what's called a practice approach to learning is we think this is how we live our lives. When we think about mathematics and mathematics education, we can worry about what people have in their head, but the only reason we need to know something is so we can do something. And sometimes what we know isn't as important as what we do. I can know that smoking cigarettes is bad for my health, but I can still smoke cigarettes. So what I know and what I do don't necessarily correlate, but it's what I do that's important. So in terms of education, we can be interested in what teachers know and think, what they believe, but in the end, the only time education happens is when the teachers and the students do something together in a classroom. So when you do with your students, when you talk to them about learning, you'll talk about the knowledge they develop, but the knowledge they develop is only important because they will do something with children in a classroom. Otherwise, it doesn't matter what they know. Does that make sense? Yeah. So this is why we started to look at what happens in classrooms rather than asking what teachers think or what they believe. So this is what we call an ontological perspective. I talked a little bit about this on Tuesday. I'm not going to go through it in detail now, but it's where we're going to focus on what happens in life, how it unfolds in time and space. And this is the focus we've taken towards learning. Now, I'll just talk quickly about the term practice. By practice, we mean what people engage in and how they, the things they do together. It's not just something simple, but sometimes if you have read someone like the philosopher Joseph Dunn, he talks about practice like a practice of medicine or the practice of law. If you read another philosopher, they'll talk about practices as a way of things we do every day. So you can have a practice of playing the piano. You can have a practice of teaching and those sorts of things. Now, that's enough about that. We don't need to, I don't want to bore you again, but if you're really interested, you could read this book. This is one of the books we've written. Now, this book came, we did a 4-year study of classrooms, and we visited classrooms and we spent a lot of time looking at it. And after 4 years, we developed this theory and we wrote about it in this book. If you're interested, don't buy the book. It costs very expensive. I can send you a copy by PDF. It's free. Just don't tell my publisher. But we wrote about it in the book. And this book, this theory has been picked up by education, but also in medicine, accounting, environmental science. It's about people understanding what they are doing to try and practice their profession. And in short, what it says is practices are made up of the things we say, the things we do, and how we relate to each other. And those things are enabled and constrained by conditions. Okay, we can talk to each other because we have a language. Incidentally, here we can talk in English because you are very kind to me. I think I'm the only one here who only speaks English, and yet everyone is doing the conversation in English. Your English might not be very good, but my Indonesian is terrible. Terima kasih. So we can do this talk together because at least you are willing to put yourself out to listen in English. So that's the theory. If you want to get people to read your work, have a good theory. If you want students to read your work, don't talk about theory. So what the theory says is what we can do is enabled by the conditions that are around us. All right, so this seminar is done under various conditions. We've got some people online and we've got some people in the room. The way you in the room are having the seminar is different from how the people on the line are having the seminar because the conditions are different. And these things change as we go along in time. So when we have conditions, it enables us to do some things and it constrains us from doing other things. So there's certain things we can do today and there's certain things we can't do, but it doesn't tell us what to do. It just gives us a range of things we can do. So one of the key things about this is that where it happens matters. Where something happens is important. It's important when we talk about education, that what happens in schools here in Malang is different from what happens in schools in Australia. And one of the things I said on Tuesday, I think it's really important that in our faculty, we research and understand how children and adults learn mathematics in Malang. We shouldn't be just getting the books from America and trying to copy those things here, because people here are different. So where something happens is important. And when we talk about where we're happening, often people say, oh, it happens in a context. And I think it's something more than that. A context is like a container where something occurs. But saying it is in the site means that where learning occurs is part of the site. And what you learn is part of where you learn it, and where you learn it is part of what you learn. It's not just a box where something happens. So the next thing then, on Tuesday, we talk about what is mathematics. And of course, everyone knew the answer because everyone was involved in mathematics. So today I've changed the question. I've asked the question, what is learning? What does it mean to learn something? And whether you are here as a mathematician who teaches at university undergraduates, or if you're here as a mathematics educator who's involved in how children learn at school, you must know the answer to this question, because that's what you do with your life. So what is learning? You don't have to tell me your answer, but it's worth thinking about. I talked to a colleague, a close colleague of mine called Jean Lava. And she studied education for nearly 60 years. And I said to her, well, what's learning? And she said, you know, I think we don't have any idea what learning is. Because every time in research we talk about learning, we actually talk about teaching, as if they're the same thing. So the question is, what is learning? Here's some definitions from the dictionary. All right, from Dr. Google. The process of acquiring new understanding, knowledge, behaviors, skills, values, attitudes, and preferences. Does that sound reasonable? When you're learning something, that's what you're doing? Second definition, knowledge acquired through the study, experience, or being taught. Well, here's one I would commonly heard. Learning is the process of transferring knowledge from the teacher to the student, bypassing the brains of both. That's supposed to be a joke. All right, but all these things talk about knowledge. And even if you're I don't know if any of you coach sport, when we try and coach people in sport, we try and give them knowledge, but in the end, we don't want them to know something, we want them to do something. If I coach you in badminton, you could tell me everything about badminton, but what I really want is you to be able to do it. So learning is more than just knowing something. So here's what we've come to think learning is. Learning is a process of being stirred into practices. So therefore, learning mathematics is the process of being stirred into mathematics. Learning science is the process of being stirred into the community of science. Or learning mathematics is learning how to go on in mathematics. So if I learn mathematics, I learn how to keep going in mathematics after I finish with the class or whatever I'm learning. And what that means is we don't just learn knowledge embodied in our minds, but we also learn how to feel we also learn in our bodies. We learn how to feel things. We learn how to interact with others and the world. I've talked to people adults about their learning in mathematics. And some of them have started crying because they feel so upset about what happened in the past. They're so traumatized. So what did they learn about mathematics? Well, they probably did learn some knowledge in their head, but they also learned that they don't like it, that it's scary, that it's hard, and that they want to avoid it at all costs. Who taught them that? Me. I was their teacher. I taught them that. But I didn't realize that their learning was bigger than just putting some knowledge in their head. And I ignored these other things, and the lessons they learned were probably more powerful than the actual knowledge they learned about mathematics. So what does this mean? Well, first of all, it means that learning mathematics is complex. Something that is complex is like a bunny rabbit. A bunny rabbit is complex because it's all interrelated. I can't take a bunny apart and put it back together again. A clock is complicated. All right, a clock I can pull apart, study it, and put it back together. So I can't take learning apart, study it in its bits, and put it back together. I've got to look at it as a whole. I can't just look at knowledge. I've got to look at what they learned in their bodies and their feelings as well. And I'll press the right button. What it also means is that mathematics education needs to be responsive to the needs of the learners in any particular site. So when you come to teach a group of people about mathematics, you can't just roll out the lesson without any consideration to who is in front of you. You need to start with what they already know and understand and feel about mathematics. And that's where you start to teach from. You have to respond to the people in front of you, because mathematics education is not about mathematics, it's about the people in front of you who we're teaching. I'll give you an example. This picture here is from a part of Australia, not far from here actually, called the Kimberley Ranges in northern Western Australia. So from here, it's probably closer to you than it is to my place. It's a beautiful part of the world. And we went out to this area and asked mostly Aboriginal students some questions. We said to them, how far is it to the river from their little village? How far is it to the river? Every single student in the school gave me a reasonable answer. Every single one. But not one of them gave me an answer of how many meters or kilometers. They all said to me, 15 minutes, 22 minutes, or something in minutes. Now, in Australia, we have a whole series of tests that students have to do. It's called NAPLAN. It's a bit like TIMS or PISA, same thing you would have done. All these students got those questions wrong on the assessment because they'd learnt about distance in a particular site and they answered in response to their site. So they did learn about distance. They just didn't need to know how many meters it was. They needed to know how long, because they usually walk to the river. So you can see that they did learn a lot about distance and measuring distance. They just didn't learn what might have been written in the curriculum and tested in the test. So what they learned was very specific to where they are. Now, the problem with that was all these students did the test because everyone had to do it in Australia. And then from that, the government concluded that they're all really bad at maths because they couldn't answer the question. Where in fact, they probably were better at it than most of the students in the city who got it right. So what would this look like in terms of an example if we were working with actual students? Let's say we wanted them to find the area of a rectangle. Maybe this was the topic in the curriculum we had to cover, area of a rectangle. So how would we start? Well, probably what we'd start is say, well, let's find a space that they know of, maybe their classroom, and say, let's find the area of the classroom. How much space is in the classroom? Then we'd talk and do some experimentation with the children. First of all, so they could understand what area means. Right, it's quite a difficult concept, the space inside something. And then we might need to talk to them about standard units a bit later on, but not at the start. But through that, they could understand those things. If we then experiment by trying to find the amount of space inside the classroom, they also might be able to measure lengths and calculate areas. Right? They might start by measuring it in how many steps it is across or something like that. They could also then learn to measure the need for standard units. Because I might do my steps and then Latifa might do her steps and I will say it's 12 steps and Latifa will say it's 15 steps. So we need standard units. So we could teach them about the mathematics of standard units at the same time. And then they might understand the relationship between area, length, and breadth as well. Because what we're doing is creating a learning situation where they engage in the mathematics practices more than just learning the formula area equals length times breadth. They're engaging in mathematics with their bodies, their minds, and their feelings. And that way they might then be able to go on and find the area of other rectangles. So this is more than just learning the formula area equals length times breadth. If we took a textbook approach to this, we would start by saying the formula for the area of a rectangle is A equals L times B, and then would get them to do some exercises. And in the process, they might learn the area formula, but they wouldn't learn any of the other stuff. So that's why we want to try and make it so they get that broader understanding. It's not that hard to do, but it's worth thinking about it as a bigger process. Now, one of the things is important is if students do learn the formula, we still don't know what's inside their head. The only way we will know what's inside their head is if they do something, if they practice something. So even if we do the formal way, the only way we will know what's in their head is by what they do. So we're arguing, why don't you just start with what they do? So maybe it will look like this. Often, if we teach students about mathematical ideas, we teach them the concept or the idea or the rule. Then we get them to practice some. And then after they've practiced some, we say, oh, well, here we'll help you apply it somewhere else. And I don't know about in Indonesia, but in Australia, what always happens is the students can often learn the formula or the rule. They can do the practices that are always straightforward. And then you get to the one where you have to apply it and they go, I don't know what to do. Because it's different sight. And we can see it's the same thing, but they can't necessarily see. So my suggestion is you look like this. So instead of starting with the concept, normally we start with the concept and the idea, and then we apply it to a problem in context. I think you're better off to start with a problem in a context, extract the mathematical idea, start with a problem that they need to solve, extract the mathematics from it, and then they'll be able to apply it elsewhere. So if I wanted students to understand about integers, I would start by talking about maybe the temperatures in Ireland in winter, where the temperature goes below 0. Right? No point talking about the temperature in Malang because a cold day here is what, 20. Right? But if you go to Russia or Germany or something, some days it's minus something. Talk about the temperature, then you can abstract the mathematical ideas and then they can apply it somewhere else. All right, so The next question I wanted to ask is, what has schooling done to learning? What has schooling done to it? Because what's happened is everything that's important we want students to learn, we keep putting it at school. As if school's the only place you can learn something. Incidentally, probably what's the hardest thing you've ever learned to do? Probably to either walk or to talk. Where did you learn it? At home? Who taught you? Nobody. You just learned it yourself from hanging around with people who are doing it. So we're all good at learning anyway. It's just sometimes we get to school and we find out, oh, we're not so good at learning as we thought. Even though we can all walk and talk and ride a bike and do a whole pile of other things that are very difficult that no one taught us to do. So what's schooling done to learning maths? Well, first of all, the first thing that school's done is valorize content knowledge. School curriculum are full of content knowledge you have to learn. Now, there's some mathematicians in the room, so I'll be careful, but the body of knowledge of mathematics is huge. The part we teach at school is a very narrow slice. And some of it's important, but some of it's just random we've chosen to do. All right. So in Australia, we teach fractions because 30 years ago, we needed to know about fractions because when we measured things with the British imperial system, for you young ones, you've got no idea what we're talking about, but we used to talk about pounds and ounces and inches and feet. You needed to understand fractions. Now we do everything in metric. There's absolutely no need for people to understand most of the stuff about fractions. We could change the content. But maths at school is about a body of knowledge which everyone needs to learn. And we've promoted that above all other things. The other thing is we've removed the learning from the community of practice. So the best way to learn most things is in the community where you do it. Where did you learn to talk? At home. Where did you learn to walk? At home and in the community where you walk. But the stuff we learn at school, school becomes like a special place we go to learn something. And I agree, it's a good idea to have schools. But the problem is what we learn becomes stuck in the side of school. So we need to help learners take it back out of school. Because what we learn at school by nature has to be general and abstract. All right, because I can't teach specific things at school because when people leave school, they're going to go into a whole pile of different things. So I want them to learn something that's general so they can then use it in different ways. Does that make sense? Yeah. So we've got to be careful, therefore, that when we teach them at school, it doesn't get so stuck in school that it is then useless somewhere else. I'll give you an example. 13. 30. Okay. In Australia, we teach children something called times tables. Do you do that here? The children sit there and they'll sing. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. Do you do that here? Yeah, we do it in Australia. Every kid learns it. Most students are okay with their 2s and their 5s and their 10s, and they get to their 7s or something like that, and it gets too hard. The problem is, and the reason we teach them their times tables at school is so they can learn multiplication to use elsewhere. So if they go to the shop to buy something and they want to buy 5 things that cost $7, they would go 5 times 7 is 35 and they'd be able to work it out. The problem is they learn times tables at school, but they can't use it anywhere else. They don't go to the shop and think, oh, what's my times tables? They relearn it again in the other site. It's so tightly caught up in where it's learned, it is useless anywhere else. I'll give you an example about that. If I said to you, what's the 8th letter of the alphabet? what would you say? Could you say it off the top of your head, or would you have to go A, B, C, D, E, F, G, H? Right, so we've learned it in a rigid frame in that site. And that's what we also do with times tables. So if you ask a student what's outside, if they wanted to know something about 4 times 5, they have to go 1 times 5 is 5, 2 times 5, because it's so stuck in how it was learned. Because where we learn something and how we learn it is part of what we learn. It's not, we don't just do that process to end up with something at the end, which we can then shift around anywhere like we like. So we want school learning to be abstract and general because we want what we learn at school to be useful outside of school. There'd be nothing sillier than learning everything at school only for school. But that's mostly what we do. So it's built on the assumption that what you learn will be transferred. But we never teach children how to transfer. We just assume that they will do that, and yet that's the hardest part. So what that means is the mathematics you learn at school, or everything you learn at school, is generalized in a sense. It has to be learned as something that we're going to take out and use in the world. Whether that world is my other subjects or my career or just in everyday life. But in fact, it's not generalized, it's actually contained in the school site. In Australia, kids talk about what's the maths they learn. I learned school maths. There's school maths and there's other maths. Yeah. So I had a friend who's a plumber. He used a lot of maths. And I said to him, oh, so that's Pythagoras' theorem. And he goes, oh, no, that's school maths. I never use that. I just use the 3, 4, 5 triangle. Because it's a different context. But it's important that it is generalized because otherwise we can't use it anywhere else. Okay. And that's the power of mathematics. The power of mathematics is, for example, that the area of a rectangle can be summarized for every single rectangle that ever exists into one formula. Area equals length times breadth. As long as it's transferred. Okay. So this is Jean Larve, who researched learning for about 60 years. She said, learning transfer is assumed to be the central mechanism of bringing school-taught knowledge to bear in life after school. We assume that everyone can transfer. All right, so if you think of all the research we're doing about learning at schools, whether it's about doing proof, whether it's about thinking skills, higher order thinking skills, anything like that, the reason we teach the kids to do it is we assume that they will transfer it to other places. The question is, do they transfer it? So therefore, if learning is always at school, then having it being able to be transferred is of the utmost importance. Because if it's not transferred, then it's a complete waste of time. We will put kids at school for 12 years for no reason. Does that seem reasonable? No? Okay, I'll keep going. All right, so transferring is a problem. And this is made more difficult because maths learning by nature has to be generalizable and abstracted, particularly mathematics learning. And in fact, that's the power of mathematics, that it is abstracted and general. That's why we do mathematics. Okay. So this is the key thing. When we learn at school, it's not just for school. has to be transferred to other parts of school, has to be transferred for further work, education, and everyday life. If you've taught, whether it's at university or at school, have you ever taught some children or some students something, and then you come back the next day and you say, do you remember what we did yesterday? And they all go, no, we don't. Or do you teach them something about triangles, similar triangles, things like that, and then the next week you do trigonometry and they don't see them as connected in any way whatsoever because they've put it in a box. It's not shifted anywhere else. It's stuck in a system. It's stuck in a way that's too rigid. Their learning is being made rigid and therefore useless. So we need to think about learning in a different way. So here's the problem, at least one of them. While we teach mathematics so it is useful for everyone everywhere in their life, so they learn mathematics and then they go and do physics and they can use the mathematics to help with their physics. So they learn mathematics and they go home and they paint their walls on their house and they know how much paint to buy. So they learn mathematics and then they can read the newspaper with details about statistics from various reports and they can understand them. The problem is they don't. Maybe not in Indonesia, but in Australia, they don't see it as relevant. They don't transfer it. They don't understand it in a different context. They can't use it to solve problems in their life. Which means what we've done at school has not served the purpose we were hoping for. Right? So we get kids at school and some who come to university, we teach them for 12 years, maybe another 4, so they can do something with it. And the problem for 90% of them is they can't. They've learned they can't do it somewhere else. So we've come to the conclusion that we need to think about learning in a different way. Because if we keep doing what we've been doing before, we're going to end up with at least 90% of the population learning things about mathematics that are not helpful at all. Right. So I don't know what it's like in Indonesia, but in Australia, the figures are about 90%. 90% of people finish school. They think it's boring. It's really hard. It's irrelevant for normal life and it's useless. So if you're in class, they might say, why do I ever have to learn this? Now, the challenging thing for me as someone who teaches and researches about mathematics education is these things here are things they've learned in mathematics class. They didn't learn it somewhere else. They learned it in the mathematics class. The very place you would hope they would learn it was important and relevant and exciting and interesting, which means inadvertently, I have taught them this because they learned it sitting in my class. I didn't mean to teach it, but this is what they've learned from being in my class. And in the end, it doesn't matter what I teach. What matters is what they learn. Now, we know this now for nearly 60 or 70 years. We've known this. Is it true in Indonesia as well? Yes. But we still do exactly the same things we've been doing. And we try and find ways to better help them do things at school so we can then test them at school and give them a grade at school because everything is contained in that school system. So if I learn something at school, what do I need it for? The test or the exam, which is also done at school. And after those, I've done those, I don't need to remember it anymore because it only sits in that system. So what would mathematics learning look like if we were trying to help students to learn to go on in mathematics, in their career, in their life, in the other subjects? What would that look like? So here's some implications, at least from what we found from our research we've done so far. So if learning mathematics is not just to put stuff in someone's head, which we can't do anyway, that's another story. It's not how to do mathematics, it's how to go on in mathematics, how to think like a mathematician. How would I teach so when they finish, they want to go on in mathematics? How would I teach so when they finish, they think, wow, this is interesting, I really want to do some more? How could I teach so when they finish, they go, this is really useful, I could use this in a range of places? How could I teach to do that? Now, I'm not saying we change all the topics we teach. I just think we need to change the way we think about how students learn about it. It's about thinking about learning being more than just something we're putting in people's heads. All right, so up until now, almost every piece of research from all over the world about learning is always epistemological. It's about knowledge and cognition. Even the research about physical education is largely based on a cognitive understanding. How can I teach them to learn how to get something in their head so they can do something? We're suggesting we need to think about learning as a more holistic, bodied way of doing something. And what might that look like? How do you do that? Well, you learn it by participating in the practices of what people do. How did you learn to walk? By walking. How did you learn to talk? By talking. How did you learn to play basketball? By playing basketball. How do you learn mathematics? By doing mathematics. And what does doing mathematics look like? I don't think it looks like watching the teacher put some notes on the board, copy them in your book, and then doing 30 exercises out of a textbook. There might be a place for that sometimes, but if that's all you do, then that's what students will think mathematics is. I know you're behind me, so you can't see. I don't catch your eye. Okay. We need to understand that having maths at school is a good thing because everyone gets to do some, as long as we make it interesting and relevant for them. But it also means it is abstract in nature because they have to then take it out of school and use it somewhere else. It would be a complete waste of our time if we only taught students at school so they could do a test at school, do a PISA assessment at school, do an exam at school, and then it had no relevance outside, or if they weren't able to transfer it outside. So we need to think about how we can make sure it's transferable. We also need to think about what restrictions having it at school puts on mathematics, because we have to write it in a curriculum document. So perhaps one of the things we might think about is what maths should students learn? To me, one thing would be really valuable for people to learn is estimation. But we can't do that at school because we can't test it in a written exam. Right? I've been in cars driving on your roads. People seem to have a very good sense of estimation because you get very close to each other, but you don't hit them. All right? But I think having maths at school, it restricts what maths we can do. And those of you who are doing research in mathematics education, what are the implications? The first one is I think we need to focus more closely and differently on learning rather than teaching. Because mostly when we say we're researching learning, we really mean we're researching teaching. So if we start with the learners rather than starting with the curriculum and how we'll teach it. Incidentally, if anyone possibly wants any of these slides, they already have a copy. You're more than welcome to have them. And I think mathematics educators and researchers need to urgently look at learning transfer. How can we teach so it gets carried outside this place? So, learning is complex. I think we need to give up the search for what we call best practice. All right? In Australia, we're always looking for what is the best practice? What is the best way to do it? And the answer is there is no best way of doing it. It depends on the kids in front of you, the teacher, the context of the community. So we need to find out what's the best way to do it here, which is why it's urgently important that maths education researchers, even if they go and do their PhD in Ireland, they come back and collect their data here and find out about what's happening here. Already talked about that one. A final word. This is a quote from our book we wrote. If teachers are obliged to follow all the available advice too slavishly, if they take their eyes off the students in front of them because they're obliged to listen too closely to advisors and administrators and curriculum writers, they may find themselves working at schooling rather than for the good of the students and society, which we would call education. In that case, the syllabus, instead of being a source of guidance and inspiration for teachers and students, will become a litany of imposed tasks which teachers and students cannot do justice to. In Australia, we have a curriculum. It has so much content in it that no one can ever finish it. It's like one of those chest of drawers where you keep putting more t-shirts in even though it's full, and you buy a new one and it's overflowing. And so what happens? The teachers just have to teach everything regardless of whether the students in front of them have learned it or not. Their job is to teach the curriculum. No, their job is to teach the children. And so the curriculum becomes like a burden on them rather than something that helps them do their job. Anyway, that's where I live. That's me playing beach volleyball. I'm old, so I'm very slow now, but you still got to do it, otherwise you'll seize up. And if any of you are interested in maths education, we have a conference here next year, and Lutherful's coming. I'm sure he'll sponsor from the department anyone who wants to come. So thank you very much. Kia ora matasi.
Thank you very much, Professor Peter Grootenboer, for giving such an informative and comprehensive presentation. Ladies and gentlemen, now we come to the question and answer session. I will give the chance from one of participants to ask directly to Professor Peter Grootenboer. Please raise your hand for on-site participants, or for online participants, please click raise hand button so the host will let you speak directly. Anyone who wants to ask directly to our speaker today? Okay. Please,
I know it's after lunch, and after lunch everyone wants to have a sleep.
Yeah. Okay.
That's why I had coffee at lunchtime, but stay away.
Thank you very much, Bu Latifah. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, Professor. To be honest, I'm glad to meet you in this the national conference, be our adjunct professor. Even though you make me getting a lot of confusion because your language. Not only, I think, my partner Pak Onggo sitting over there, it's also getting a lot of confusion. but don't worry. I think you can get my point. You can get my point.
Yes.
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 Okay, I'm sorry. But don't worry. I can got your main idea for your explanation and your presentation. So I want to say thank you very much for your insightful presentation, your insightful explanation, I think, about the fundamental aspect of learning mathematics, not only learning mathematics, but also teaching mathematics, the philosophical aspect of teaching and learning mathematics, I think. But there is some question in my mind, Prof. If we're looking for the topic of research in mathematics education, also in educational field, I think, conducted by a researcher over the world, we will find a lot of article about higher order thinking skills. If we're looking for in maybe Scopus database and others, I think we can find a lot of article about higher order thinking skills, like critical thinking, and then creative thinking, and so on. If we make relation between higher order thinking skills and our topic that have you explained about learning transfer, you explained recently, how important we facilitating our student with teaching and learning activities that can improve their higher order thinking skills. And if it's important as a teacher, I think most of the participant of our conference is teacher and lecturer. What should we do? What should we do? Because from my opinion, from my point of view, this is important, but not easy. Not easy. It's difficult to develop, to make teaching and learning activities that can promote our student higher order thinking skills. Yes. It's not important, I think, and not easy. It's difficult, but it's important. Yes. Yes. So, as a teacher, what should we do, in your opinion, as an expert in our conference? Thank you very much. That when against my confusion, it means that we need more time to be apa namanya meeting like this conference at this like this moment.
Yes.
And I think our head of department will facilitating us to make more event like this. Thank you very much, and sorry. Assalamualaikum warahmatullahi wabarakatuh.
First of all, sorry, I usually speak too fast. I often try and put a lot of notes on the PowerPoint, so at least you can read it. I can also send you a paper, which I've already sent it, the Merger one, which is similar, which if you're interested. I think higher order thinking skills are, as you said, of interest everywhere. In my opinion, how we should not teach higher order thinking skills is by saying, right, today I'm going to teach you how to do critical thinking. This is how you do critical thinking. Right, now do critical thinking on this example I give you here. I think we learn higher order thinking skills by solving issues and wrestling with problems, by doing it. So I would try and find a story or a situation where I give them something and say, how would you solve this problem? How do you think about this problem? And then try and get them to do higher order thinking skills by what the conditions I create. So, for example, I'll try and you might say, we are in America and they want to have Donald Trump as the president, and some people say no. What do you think? How would you decide? Because some people think he's wonderful and some people think he's terrible. That's probably not a very good example. The university wants to build a new building, but the only space left is where there is a colony of turtles. Should we destroy the turtle habitat and build the building, or should we look after the turtles and put the building somewhere else? You would know for your, it would have to be something that's requires critical thinking for your students. When COVID was here, we could have critical discussions about, should we have restrictions or should we be free? How free should we be? In Australia, the government said, no sport, because we'd be too close. But if I play football, yes, we do get quite close to other players. But if I play golf, we're nowhere near each other. So we could have a discussion and ask the students to decide how the government should help us stay up. I'm just making up situations, but I'd try and find something that's interesting for the students to think about and then do higher order thinking. I think, and then we could ask them to say what they did, and we could encourage them with some things. We could give them some ideas, but it's always in the process of actually doing some thinking about something. I've seen lots of programs which teach higher order thinking. Today we're doing critical reasoning, tomorrow we're doing this, the next day we do this. And what happens is the students can do them in the class, they just can't use them outside the class. So I would always try and have them doing critical thinking rather than learning about critical thinking. In the same way, if I want to learn piano, I want them to play the piano and learn, not learn about playing the piano. If I wanted to teach you about badminton, you're probably already very good at badminton, but I wouldn't sit you in a classroom and say, right, we're going to have 10 weeks where I talk to you about badminton. And then in week 11, we go out and start playing. We would learn to play by doing it. We would learn mathematics by doing it. We would learn critical thinking skills by doing it. I always want students to do it. And I have to create a space where they can be guided towards some of the things I want them to do. Does that make sense? And like you said, it's not easy, it's much harder. One of the hardest things is, if with mathematics, you start teaching the students by giving them problems to solve, and they're used to you standing there going, today we learned Pythagoras' theorem, copy this down. If you change to do something else, the students say, sir, you're not telling us, you're not teaching us properly. So that makes it hard as well. But I think if we want them to learn something useful, they have to learn by practice. I would say practicing it or doing it. Now, on your other question, Latif, that one. Latif full, the full one. We've already talking about how we can work together. My job as an adjunct professor here is to help people in this faculty and to work with people in this faculty. I cannot read everyone's paper. I cannot work on everyone's project, but I can do some. And so we're working at how we can do that. Because just giving a lecture like this is not particularly useful because you get ideas, but we can't talk about it. So I agree. I'm looking forward to opportunities to do more dialogue where we can talk about things. Thank you.
Any feedback from Pak Tommy? Okay,
That's enough.
thank you so much, Professor. Is there anyone else who wants to ask directly to our speaker today? Okay, from the chat room, Professor. From Irma Rahmah Hidayah. I think the question from Pak Suka is a bit similar with Pak Tommy's question, so we can next to the Irma Rahmah Hidayah.
Okay, so the one about low order thinking. So my answer to that is, if they are low order thinking, if they're struggling, they don't get better by, you don't have to do some basic things before you then start doing the thing. You just need to find mathematical practices that they can do. And sometimes you'll be surprised at how they can do things when they are in context rather than doing something that's not. One of the things I used to do with my students when I start, sorry, I'm too fast. I used to ask the students, what are you interested in? I give them all a big piece of paper and ask them to write in the middle, what are you interested in? And then I'd say, now write down everything that's mathematics in your thing. So they might put down, I'm interested in football. What's involved? Keeping score, tables, statistics about performance, the size of the field. They would write what things are in it. And then I would say to them, good, now you have to go and do a project and find out about the maths, these things you've said. So what I did was I started what the students were interested in rather than starting with mathematics. And then if the student came and said to me, this is boring, I'd say, well, don't blame me, it's your hobby, you chose. But I always try and start with what the students were interested in, whether they're low, middle, high, because invariably the low ones can be high in some things as well. The other question. No, that's okay.
Okay. She's interested in design and develop mathematics learning based on the local wisdom. So the question is how to integrate and maximize the local product value and context in mathematics learning.
Okay. This is a very good question. One of the things that happens with mathematics is we now have this body of mathematics, which is largely what I would say Western mathematics. Now, it didn't all come from the West, but it looks the same everywhere. One of the good things about maths is whether you go to Japan, Indonesia, Russia, Africa, it looks the same. We can talk to each other in numbers because we all have the same. There's not numbers that are different in every language. They're always the same. But from the example I showed you from my Aboriginal students, Western knowledge would say they are very bad at mathematics. But if you ask them the right questions, if you start the curriculum with what they're interested in, they are very good at mathematics. So these students, you could take them, blindfold them, drive them 50 kilometers from their home, put them out the car, take the blindfold off, and 2 days later they would walk home because they very good at direction. They knew from the sun and the stars, the conditions of the landscape. But if you test them on Western mathematics in a textbook, it says they are very bad at direction. But in fact, they were better. So if you can start with where they're at and what they understand and local wisdom, there's always some mathematics involved. And if necessary, you can then connect that to the standard mathematics of the curriculum. So the students I showed you who said, how far is it to the river? They said 15 minutes. When we taught them about metric units like meters and kilometers, we didn't have to start with them as if they knew nothing about distance. We just had to find a different way, a different scale of representing it. So the question wasn't, how far is it to the river? You don't know. I'll teach you about meters and kilometers. The question was, how far is it to the river? 15 minutes. How many meters could you walk in 15 minutes? And then they could learn it quite easily. So it's always about starting with the needs of the community and the learners where you are. So in Malang, what are the needs of the learners here? What do they understand from the local context? Given the design of your things, I'd say they have some very good geometric understanding about rotations and enlargements, things like that. So if I was going to start teaching about it, maybe I'd start with batik, because they already have the concept. I just have to show them what it looks like in a mathematics concept.
Okay, thank you, Professor. Apparently, we still have enormous question, but however, due to limited time, we need to end our discussion. I'm sorry for participants who asked but not yet to be answered. For participants who want to ask more about the topic from Professor Peter Grootenboer, you can contact him on his email on the CV. Ladies and gentlemen, we finally come to the end of second plenary session. Okay, yeah. Professor Peter said that he will be here today and tomorrow. Perhaps for offline participant, you can talk to him later. Okay. We finally come to the end of the second plenary session of ICoMathApp 2023. We would like to say thank you again for Professor Peter Grootenboer for his insightful and interesting talk, and to the audience for your active participation. Please give applause again for the speaker and for you all. Thank you very much. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh. Over to you, Sefira and Rama.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Well, thank you so much, Mrs. Latifah. And ladies and gentlemen, once again, please give our appreciation for Professor Peter Grootenboer. A very informative and interesting presentation. But before that, Professor, to express our appreciation, we present Professor Grootenboer with a token of esteem from our department. And we would like to request Mr. Latiful Anwar, the head of Math Department of Universitas Negeri Malang, to demonstrate a willingness to ceremoniously present tokens of appreciation as symbolic mementos.
And also, we kindly request to Professor Grootenboer to be willing to accept our manifestation of gratitude.
Well, ladies and gentlemen, in the spirit of united through knowledge, we extend our heartfelt thanks to Professor Peter Grootenboer for his invaluable participation. His endeavors continue to inspire us in the pursuit of mathematical. Please give a big round of applause for Professor Peter Grootenboer, ladies and gentlemen. Well, thank you so much, Professor Peter and Mr. Latiful Anwar.
Before we continue to the next agenda, to all participants who have not yet filled out the attendance links, please fill it in the attached link attached to our Zoom chat room. Thank you.
Bapak dan Ibu sekalian, sebelum kita pergi ke agenda selanjutnya, untuk partisipan ataupun peserta yang belum mengisi presensi yang dibagikan oleh panitia, tolong diisi presensi yang sudah dibagikan oleh teman-teman panitia di kolom chat room. Terima kasih.
Ladies and gentlemen, before we start to the next plenary session, we will have a coffee break until 2:30 p.m. For all on-site participants, please enjoy the drink provided by our commute. Thank you.
Bapak dan Ibu peserta attendees, sebelum kita pergi ke pleno selanjutnya, kita akan coffee break lagi sampai pukul 2:30 waktu Indonesia Barat. Jadi untuk partisipan offline, tolong nikmati drinks provided by our committee. Jadi tolong nikmati coffee break yang sudah disediakan panitia. Kita akan coffee break lagi. Ya, alhamdulillah sekali.
Dan jangan lupa untuk join kembali pada pukul 2:30 waktu Indonesia Barat. See you.
Sampai jumpa. Mari Bapak Ibu, monggo kita sama-sama coffee break. Biar kita sama-sama mengisi energi untuk pleno selanjutnya, untuk menerima ilmu dari speaker kita.
Selamat siang, Pak Onggo. Prof. Onggo.
to our third plenary session. First of all, I would like to introduce myself. My name is Asmianto, and I am the moderator of this plenary session. You will be hearing a presentation from Professor Dr. Bhakti Satya Budi Stepan Onggo. Before we get started, please let me read a brief biography of our distinguished speaker today. Dr. Bhakti Satya Budi Stepan Onggo is currently a professor of business analytics at the University of Southampton, UK. His research area are simulation modeling, methodology, symbiotic simulation or digital twins, agent-based simulation, discrete event simulation, with application in operation and supply chain management. Besides that, his research fields also in hybrid modeling. For the academic background of Professor Stepan Onggo, he received his bachelor degree in computer science from Institut Teknologi 10 November, Indonesia, and his Master of Science from Lancaster University, UK, and finally he got his Doctor of Computer Science from the National University of Singapore. And here are some of his publications. Okay, before the presentation start, I would like to tell you how the presentation will go. First, I would like to give the time to Professor Dr. Bhakti Satya Budi Stepan Onggo to present the material for about 45 minutes, and there will be about 15 minutes for the Q&A session. For online participant, if you have question or comment for Professor Stepan Onggo, please write them down in the chat room of the Zoom meeting. While for offline participant, you can ask directly after the material is delivered. Without further ado, now allow me to welcome Professor Dr. Bhakti Satya Budi Stepan Onggo, who will be speaking to us on operational research in disaster risk management. Professor Dr. Bhakti Satya Budi Stepan Onggo, the floor is yours.
Yeah, thank you for very kind introductions. Can I check whether the committee will run my presentation, or should I share my screen?
You can share your screen, Professor.
Professor, are you having a difficulty to share your screen, or do you want us to share the screen? Okay, that's it.
Okay. 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 Thank you for the kind introduction. Sorry for the technical detail. Sorry, the technical issue, because I thought the slide will be just operated by the committee. Okay. Anyway, I hope you can see my screen now. So my name is Stepan Onggo. Today I'm going to talk about the operational research in disaster management. So here is my detail. So if you can go to my website or send me an email, or even if you want to connect me via Instagram, you can simply just scan the QR code over there. Okay, let me start with the background. So because probably not all of you are familiar with disaster management. So in general, in disaster management literature, we classify, or we split the phases in disaster management into 4 phases. One is the mitigation. So mitigation meaning that we try to avoid the disaster if possible. If not possible, then we try to minimize the risk. So that's why we are talking about risk analysis here. We are talking about the hazard analysis. Risk analysis is basically a combination between hazard analysis and vulnerability analysis. Hazard means we want to know what is the probability that we are going to be hit by an earthquake, for example, or what is the probability of we are going to be hit by floodings at certain location at certain time. That is hazard. Vulnerability analysis is we are talking about, okay, if we are now hit by a flooding, what would it cost us? How many lives will be lost? How many damages will be incurred, and so on and so forth. That is vulnerability analysis. Now, here again, as I said earlier, mitigation is focusing more on the disaster risk reductions. We try to reduce the risk as small as possible. And one of the way of doing it, we can also build a resilient infrastructure. Say, for example, earthquake-prone materials should be installed for buildings, for example, and behavioral analysis also. So this is about, say, preparing citizens if some a hazard happen, a disaster happens. What should they do? So this is a kind of mitigation. So this is the mitigation phase. Moving on, just before the disaster happens, we are going to preparedness. So this is usually we are talking about where to locate our warehouses, where to locate the healthcare services, where to locate where the shelters are, how to design or define the evacuation routes. So these are done before the disaster happens. So this is what we call preparedness. And then disaster happens. When disaster happens, then the next phase is called response. Now we need to respond to the disaster. We need to help people. So this is, we are talking about the allocations, because previously we have already allocated relief items in several locations. Now it's time for us to allocate. Okay, for disaster in location X, we need to supply the items from location Y. So that is allocation. So we decide who is going to supply where. Now, once we know the allocation, then the next step is transportation, how to send or deliver the items to the locations. Another response is the evacuations, how we can help people to evacuate to the predefined shelters or predefined safety points. So that is evacuations. And quite often, we need to decide where to locate temporary facility location. For example, if the permanent facility locations are not enough or some of them are damaged, then we need to have temporary facility location. For example, for shelters, we probably need tents, for example. Yeah. For warehouses, we probably need a mobile storage units, for example. Okay. So once the response is done, so immediately after that, we need to think about recovery. How can we go back to normal life and better? So this is where we talk about waste removal, for example, in after flooding or after earthquake. Then we need to remove all the debris, so we need to remove all the waste. So this takes a good planning. And then we need to discuss about the long-term effects, because, for example, quite often after a disaster, there will be a lot of mental health issue. So also maybe a lot of amputations, for example. So then we need to deal with the long-term effect, not to mention about the effect on economy as well and social life. So basically, recovery, usually if done properly, we want to build back better. So we don't want to go back just like before, but we want to go back to a better place, better condition. So the next time disaster happens, we will be more prepared. So that's why there is a loop in there. So I hope that gives you a brief introductions of what disaster management phases are. Now, let me just give you some detailed example about mitigations. Remember, in mitigation, typically we're talking about resilient infrastructure and behavioral changes. So for example, the mitigation example include relocation of people living in high-risk areas. So here, then the decisions is talking about what is the right subsidy. So to entice people to move from the living in high-risk area to better, safer areas. How can we encourage people to change their farming behaviors? For example, slash and burn behaviors that can be quite damaging to environment, and that will have a great impact on natural disasters. How can we incentivize people to do more tree planting, reforestations, and so on and so forth? So there is a need of educations. And I already mentioned about the resilient infrastructure of housing. So we learned our lessons from the Turkish earthquake earlier. So the main issue was the quality of the buildings. So that's why a lot of people in Turkey were angry to the government. So that is one of the issue here. So and better regulatory or organizational infrastructure. Remember, for example, Indonesia before Aceh tsunami in Aceh, we didn't have the NPP, for example. So then, but now we are getting better. Now we have the right organizational infrastructure, and we have the some of the peraturan pemerintah or regulations. So that is really good. So the next one is, of course, because we are dealing with more and more extreme weather. This is a direct result of climate change. So we need to do more climate change adaptations. Okay. So now let's move on to preparedness. So after mitigations, then we go to preparedness. There are some examples that I can give you. I'm talking now in the language of that you are familiar probably in operational research. First is how to locate critical facilities. So critical facilities include shelters, hospitals, warehouses, and so on and so forth. So this is a very typical what we call facility location problem in operation research. Yeah. And in disaster management, more and more paper, they are talking about, they are considering secondary disaster, because quite often a disaster is followed by other disasters. Yeah. An earthquake typically followed by aftershocks and so on and so forth. And landslides, flooding can be followed by landslides. Earthquake can be followed by landslides. I think you probably have heard about this in many examples in Indonesia. And then the next question is, okay, once we have located all the critical facilities, then we need to consider how many to stock and where. So this is what we call resource pre-positioning problem. So inventory problem. Yeah. So for example, how much rice do we have to stock in which warehouse? How many tents that we need to store in which warehouses, and so on and so forth. Okay, so the next one is, okay, once you have that, another thing is that you probably need to decide is procurement, because when disaster happens, who will provide the resources and at what price? So this is quite often in disaster management, we have kind of contract with the private sectors or contract with Bulog, for example, the state national logistic in Indonesia. And then we have some special contract drawn for them to provide certain items at certain amount at certain price. Yeah. So that is, and then we need to decide which one is the most optimal. Yeah. Okay. The next one is that given the next problem is called lot sizing. We know that a lot of government agency they have annual budget. So how much to buy and when, that has to be decided properly. So that is another example. Now in disaster management literature, people often combine these problems. So for example, then we can combine facility locations and prepositioning, for example. So they can combine both location prepositioning problem or location allocation problem or inventory. Yeah, so basically they can usually combine between different problems. Yeah. Okay, move on now. I'll give you some example that we have done ourselves. So this is the example that we have done in the context of West Java. So this is, we are working with the West Java government, specifically BPBD, West Java. and Bulog West Java, as well as the local governments. So the question here is that, so let me give you the background. So in Indonesia, like you know, disaster happens almost every day. Yeah. Unfortunately, Indonesia is in that kind of ring of fire regions. There are a lot of disasters. Now we want to decide the optimal stock for rice, because more than 90% of Indonesian, they eat rice almost on daily basis. In fact, 3 times a day sometimes. So that's why rice is very important. So we know historical price for rice. So we know also about historical demand based on the number of refugees. So this is based on 5-year data for the refugees. So you can see here for the refugees, they kind of seasonality. Yeah. Oh, sorry, you cannot see the seasonality, but you can see the variations. Sometimes very high in 2016. I think probably some of you probably still remember there are quite a lot of disasters. In 2020, this is because of the flooding in West Java, near Jakarta. Yeah. So that is Kerawang, I think Kerawang Bekasi. I think there is a massive flooding, so that is reflected in the data here. Okay, so we know historical price of rice that we need to stock. We know the demand, historical demand, and then we have annual budget. Yeah, and we have rice. We have shelf life. Typically we want to give a good quality of rice. So we can set to be a few months, say 6 months, for example, or even more. It depends on the policy. And then we also have the initial and final stock requirements, because we don't want, in this budget year, we use up all the rice, for example, all the stocks, for example. It's not good for the next year. And then we also have the Indonesia and some other developing country, when they are dealing with local farmers or smallholder farmers, there is a minimum price for rice in this case. Yeah, so there is a minimum price set by the regulations, because we cannot buy lower than that price. Of course, in our model later on, if there is no such constraint, we can set the minimum price to 0. Okay, so this book has been published in this journal, so you can simply just Google the title. And you can find the paper. Yeah, and it's open access, so you should not. It's available for you for free. Now, the question that that this paper is trying to solve is this: how much do we need to buy each month? How much rice do we have to buy each month? Yeah. Okay. So of course, for mathematical conference, we thought mathematical equations probably is a bit, it's like eating food without salt, right? Without spices. So let's see. So basically, this is our basic model. If you look at the paper later on, we modify this basic model to several versions in the paper. But the basic one is quite simple. I think some of you, even in the undergrad, who are doing undergrad, can understand it. Yeah. So basically, we want to minimize the shortages. Yeah. So meaning that we want to meet all the demand. Yeah. These people need help. So that should be our first priority. We help them. Everybody must be helped. And then the second priority will be to minimize the waste. Yeah. The reason is that when we are dealing with perishable items, and we want to minimize shortages, then waste is unavoidable. There is virtually impossible for us to avoid waste. So waste will happen. That is a consequence of trying our best to help people. So waste is a byproduct. What we can do is try to minimize the waste. Now, in addition to minimizing the waste, we want to minimize the cost as well, because in the context of Indonesia or PPPD or BNPB, this is public money. So we need to minimize the use of public money, make it more efficient. That is probably the right word. Not minimize cost, but make it more efficient. Yeah. So you can look at here. This is this is the first constraint. Basically, we want to say, I think it's easier if probably we move the C to the left side. There is a reason why we put it this way, because we want to convert it to stochastic model, programming model, and robust optimization model. So that's why we write it this way. But if you move C to the left side, it becomes minus, then it's easier. It means that the stock at time I is the same as the previous stock at time I minus 1, plus whatever that we buy, now we decide to buy, minus consumptions, that will be the new stock. So it's very simple, right? Yeah. So the second constraint is basically we want to build the relationship between consumptions and demand. So if the demand is greater than consumptions, it means we have some shortages. This is the one that we want to minimize. But if the demand is, if the consumption is less than, if the consumption is more than what is the demand, it means we don't have any shortages, right? So it means we remember, this is demand. What is consumed is demand plus the stock that we have, right? So that is possible, yeah, because we have some stocks. So that is defined. That is defined in here. So then this is also about the ensuring that at the end of the budget year, we still have some R unit of rice in stock. So we don't use up all our stocks, yeah. And this is the constraint for budget. So we need to make sure that our spending is less than the budget. And this one is a constraint for availability, because rice, luckily for West Java, is the rice producer in Indonesia. So maybe it's less relevant, but in general, we can only buy, we cannot buy greater than the available items in the market. Basically, this is the availability constraint, yeah. And L is basically our initial stock. And then we set the, at the very beginning, we don't have any waste. So that is our assumptions, yeah, which makes sense, isn't it? That in the beginning, there is no waste. If there is waste, then the waste has been taken out from the stock anyway. Okay, so that is basically our basic model. And then we, one of the things that we include in the model, this is a bit more detailed, is that we include the, because there is a waste or perishable items, so we kind of need to include that in the model. So the way it works is, maybe if you look at this diagram, it's easier. So say if we buy YI and then consume with certain amount, we consume it. And then we also have stocks, yeah. So and then this is zero means fresh. So we if after we consume some, then the leftover will become the stock at with the age of 1 time unit. So this is not fresh anymore. It's older, 1 unit older. And if we consume from the stock with age 1, and then we consume it, and then the leftover will become stock in the next step with age 2. So again, this is 2 unit or older than what 10 unit old, sorry, 2 unit older, and so on and so forth. So here, at some point, we define, say, tau here is, say, for example, if tau is 7, it means that after 6 months, this item will become a waste. Then we need to put aside for something else. So that's how it works in the model. It is represented by these 2 equations. Yeah. Okay, so that is the detailed mathematics for those who are, of course, all of you, because you are all from mathematics, likes the mathematical detail. But let's look at the result now from the policy perspective. So what does it matter for policymakers, for BNPB or for BEPBD? So this is just an example. If we use the data, the real data from the 5 years data, and then we run our model retrospectively. So as if we we can go back to the past. So we implement several models, not just 3. I think you can read from our paper. I think about 7 models. So this just we show you the 3 of them. This is the robust optimizations, also in this case, because we use 100% of the data, it means the solution is the same as the deterministic solution. This is the stochastic programming model, and this is the adjustable robust optimization model. You can see here, this is basically showing that the optimal purchasing, the optimal amount of rice to buy in each month in the past 4 years. Typically, most of the items that has to be purchased around between April and July if we use this method, optimization method, the robust optimization method. Yeah. But if you use stochastic programming, then most of the items that we have to buy is typically in July. Yeah. But one thing that you can see here, for arrow is different patterns. But one thing that you can see here, because we are only using for 5 years data, the variation is quite big. Because remember, 4 years data for to cater for seasonality, it means for every month we only have 4 data points. So that's why we can see the variation is high. Okay, now this is really, and then after this, we can also see the impact of the unmet demand. And fortunately for all the unmet demand, they are close to 0 or they are exactly 0. So it means we can serve all the people who need help, so that everybody will get their rice. Yeah. But if you look at the waste now, we can see here that this algorithm will produce more waste compared to the other 2 algorithms. Yeah. So typically waste happens in July. This is partly because of the initial stock that we have. So this is the impact of the waste. So once we know this, if you look at it from the policy perspective, then they can understand, right? Okay, so we need to get ready for this kind of waste. Is this a risk that they are willing to take? So that is the one of the things that they have to decide. Now, I said earlier, the variation is high because we only use 4 points of data. But now because we have the model, now we try, what if we have more data? So in this case, we generate synthetic data using the historical data. And then assuming we have 100 data points now. Now, then we can see, we can compare different models here. And to help us compare different algorithm, we use the expected value of perfect informations. So this is basically the difference between the expected value of our algorithm in comparison to the best solutions. Yeah. So if it is 0, that is the best is 0. So the smaller is the better. So you can see here in terms of shortage, they are quite good because it means that we can supply all the rice needed. Yeah, so that is what we want because this is our first priority. Okay, now then we move to the second priority, the waste. Now we can see the difference now, right? So if we use PCT 100, which is the most conservative, you can see it will produce a lot of waste in comparison to other algorithm. Yeah. So we can look at it from the median, or we can look at it from the 90th quartile. So then we can see the last few algorithms are better in terms of waste. Likewise, in terms of budget, they are perform better. Yeah. So that's something that we can see here. Yeah. And for the policymaker again, now because we have more data, you can see here now the variations getting smaller and smaller. It means when you make decision, it can be more and more precise. So in this case, we can see that actually now it is clear that we probably need to buy a bit more in July and a bit more in July. And you can see here, the 3 algorithms, they kind of agree that definitely government needs to buy rice in July in this case. Yeah. So that is something that is quite useful for the policymakers. And of course, this one can be applied to any other thing, not just rice. Because as long as you have the seasonality in the price, you have seasonality and the demand, and you have the minimum price, and then you have the you have to meet the demand, and you try to minimize waste. This model can be used as well. So it can be used for food supply chain, for example. It can be used for blood supply chains. So maybe it can be applicable to your case, even though you are not doing disaster management, but you are doing more on the perishable items, supply chain of perishable items. This is applicable. Another preparedness example. This is the second example. This is about facility location. So the goal is to determine the optimal location of facilities that minimize the expected time to serve all the affected regions. So it's very typical facility location problem. And then the service will be carried out by fleet of vehicles. Each fleet being based in a different facility. So each facility also have their own vehicles. And then we consider a set of locations that can potentially be hit by a sudden onset natural disaster. So when we are talking about natural disaster, we are talking about two types. There are two types of natural disasters. One is the sudden onset, like earthquake happens suddenly, or flooding happens suddenly. There are also the slow onset, like drought. Drought takes time. So that is so this algorithm is for sudden onset. So that in terms of, maybe this diagram will explain a bit better. So suppose you have the circle, the potential locations. So these are the potential for demand, the potential of location that can be hit by disasters, basically. And then we have to decide where to locate our facility, which is the pink rectangle. So we have a lot of choices here, right? But the idea here is we want to minimize the furthest distance from the facility. So in this case, the furthest distance is this one. And if you put the location, the facility in this place, then the furthest distance is this one, for example. So this is what we call what we call mixed span, in the literature. And then we consider the travel, the travel time between here has two components. One is the deterministic component, because we know that for us to travel from A to B, definitely you cannot go faster than X hours. So we know that. So that is deterministic. So we have that number here, but we also have the stochastic element, because this depends on the damages on the road. So if the road is damaged very badly, then the value of DIJ will be quite big. So we also take into considerations the damage on the in the infrastructure. So this is the mathematical model. I think I don't want to spend too much time on the mathematical model. In a way, it's quite standard, but the only things that difference here is probably we want to minimize the words mixed spans or the distance, and the rest is pretty standard. In fact, probably you can use it for exercise for the undergrad. It's quite standard. What is important for our paper here is the algorithm to solve it. We use what we call sim heuristic. So this is the idea. The main contribution of the paper is to use this algorithm to solve this problem. So in this case, basically the way it works is that we generate the solution first, initial solution. It's feasible but not optimal, and then we run it using a short, just only a few simulation runs. A few simulation runs, like 5, so it's quite fast, and then set this one as the best solutions, and then use it in the elite solution list. So these are the solutions at the moment. But if we have enough computation time, then we generate another solutions, and then again we estimate the performance by running a short simulation runs. Only a few, say 5 or to 10. And if it is better, then replace the worst in the list. So it's quite a simple algorithm. Yeah. So we basically try to find now the thing is that is important that is not explained in this flowchart is when we do the last step here, we use the bias bias selection algorithm. So that it means we try to avoid the local minima. So the detail is actually given in the paper, but that is one thing that is not explained in this flowchart. Now, once we have that, then once we finish with the iterations, we don't have enough competition time, then the elite solutions, given the elite solutions, we run more simulation now because we try to have a better estimates of the performance. Then finally, we return the best solutions. Just to give you an idea from the policy implications, so we run experiments. We compare the mixed funds with the number of facilities here. So we run our simulation with a number of facilities many times. Yeah. So if we can expect here, if you only have one facility, then the mixed fund will be the worst, right? Because you only have one facility. So as you increase the number of facilities, the mixed funds will reduce. That makes sense. Now, what is important for this result is if you look at 4 and 5, as well as 9 and 10, if you are the policymakers, when you open 4 and 5, there is a cost implications. Opening 5 facilities is way more expensive than 4. But the performance that you gain is almost negligible. So if you're the policymakers, you know that I think it's silly to use 5 facilities. It's better to use 4, right? Rather than 5, you better move to 6. So you never invest in 5 facilities, sorry. You either invest in 4 or 6, depending on the budget. Likewise, 9 and 10 is the same. So this is important for policymakers. Yeah. The next one is that also important for policymakers is for the risk analysis. So this is just show the 3 best solutions that we have. And the 3 best solutions, so this is, for example, the best solution is the red one. This is shows that how fast can you serve 100% or 80% of the populations. So this is the percentage of the populations. Yeah, so to serve the 80% of the populations, then the best solution can finish at 1900 time unit. So this can create a, okay, if I use, let's say, n number of facilities, it means I can serve 80% of the population after 1900 units. Now, the policymakers will have to make a decision. Is this the risk that they are willing to accept? If this is not acceptable, then they have to increase the number of facilities. So that is how it can be useful for policymakers. Okay. Now we move on to the next phase, response. As I already mentioned earlier, there are quite a lot of example evacuations, also vehicle routing problems. I think for people in OR, operation research, know about vehicle routing problems. So this is talking about relief item distributions. We can see it as a vehicle routing problem. Health system response, that is also a part of the response examples. This is related to emergency protocol. So when disaster happens, what is the right emergency protocol that has to be done by the hospitals, for example? Yeah. So what happened last time? Say, for example, after Cianjur earthquake, what did the hospital do to respond to the massive surge in the demand in the number of patients? So they have to do some emergency protocol. Yeah. And then procurement of additional resources. For example, the amount of items that we stock is not enough or damaged by the disaster, then we need to procure additional resources. Likewise, we need to probably add more facilities, temporary facilities. Another thing that we can also do in modeling is to simulate or to model the inter-organizational coordinations, because quite often the main problem with disaster management response is the communication between agency, between people. Yeah. And quite often nowadays in the literature, they combine response and preparedness. So that becomes problem called location allocation problem, location distribution problem, inventory routing problem, hybrid prepositioning out procurement. For example, you preposition items, but at the same time you have a auction or contract. So that is what we call hybrid procurement. Yeah. Okay, give you one last example from what we have done. So this is the for response. So the idea here is that given that we know in West Java and other part of Indonesia is the same, we have a lot of disaster happening every day. So it means we create a simulation model to generate n number of disasters. And then for each disaster, we know from the data, we can sample the locations, because we know, right? For example, let's see, flooding in West Java typically happens in, say, Kabupaten Bandung, for example. Angin puting beliung or typhoon it happens in certain location most likely. Yeah, so that's why, and we have the data, we have the data about the number of certain type of disaster in what locations, so that we can generate the locations. And based on the number of people live in the area, we can also generate the refugee, and we also have the data about refugees from PPPD. Yeah. And then this is where the mathematical modeling happens. So this becomes assignment problem. So I think for you who learn operation research, there is a model called assignment problem, where you decide which warehouse to serve which locations. Yeah. So that is called assignment problem. Yeah. So there is an assignment problem model in here. And then for each assignment, then we make a routing decisions. Again, this is another transportation problem in operation research textbook. So there is a mathematical model here in mixed delivery decisions. And then we simulate the delivery and then check whether we have finished the simulation. If not, then make the procurement decision, that the one I explained earlier, and then move on to the next day, and so on. So one loop here is for 1 day. Yeah. And procurement decision is not done every day, but it's done once a month. So sometimes it will be just skipped, yeah, for until the following month. Okay, so the paper is given in here. So if you are interested, again, it's open access, so you can just download it and read it. So this is just to give you an example. So suppose on this particular day, there are 4 disasters happens. So these 4, after we generate 4 disasters, then for each we allocate, oh, okay, for this disaster will be served by this warehouse. The one with star is a warehouse. In fact, those are bullock warehouses in West Java. So for this disaster will be served by this warehouse because this is the nearest. Likewise, for this disaster will be served by this warehouse, and so on and so forth. And then after we decide the allocations problem, the assignment problem, then we decide the transportation problem. So the shortest distance between this to serve these 3 locations is to take, this route, for example. So that is how it works for our simulation model. Yeah. Okay. Now recovery example. So this is the last stage. We are dealing about waste removal. Remember when I mentioned about that one, build back better, and so on and so forth, and address the long-term effect. And then one thing that is quite important is to learn our lesson and then fit this one into mitigation and preparedness. So next time we will be better. And a better there is no better example than Indonesia, right? In Indonesia, after the tsunami in Aceh, what happened? First, it ended the 30-year armed conflict between Aceh rebels and the government, and led to the peace agreement and first free election of Aceh governor. But the most important thing for us in terms of disaster management is the number 2. the establishment of PNTB, we learn our lesson that we need national agency that coordinate all the help, because it was the main issue with the response to Aceh tsunami was the coordination between agency. So that's why we have PNTB here. Okay. Finally, basically, I just want to give a context that disaster management is complex, a lot of interaction between different groups, organizations, and there is diversity for each group. They have their own preferences, they have their own agenda, so that's what affects their behavior. This interaction will create a kind of emergence behavior that because of the interactions, and that will create some kind of feedback loops, introducing non-linearity in the system. Yeah. And quite often it's context dependent as well. What happened in West Java may not be the same from what happened in, I don't know, in Sulawesi, for example. Yeah. So it's very context dependent, depends on the local culture, for example. Yeah. So that's why there are quite a lot of methods that actually can be applied. So operation research is one of them, which is quantitative. Also, we need to work with people from the qualitative background to understand about people. We can do social network analysis. Is quite important as well to analyze complex system like this. And simulation, of course, is really important. Yeah, this is what some of my examples, because of the stochasticity, the uncertainty when dealing with disasters. Yeah. And then soft OR, in case you are not familiar, this is help us to structure and formulate complex problems. So that is important. But my point, my message is we need interdisciplinary research to solve this complex problem. Okay. Okay, so this is basically part of my current research is trying to understand the behavior intention. So in this case, we are collecting some data from Cianjur earthquake recently. So we are still working on this one, just to give you an idea, because now we are realizing that it is important to understand people's perspective, people's behavior. So it's to put into the mathematical model. So we put context into the model. And this is another example that we also did recently. So we went to Beirut earlier this year in March, try to talk to people who were involved during the Beirut explosion in 2020. So these are the doctors, the first responders, the mental health workers who responded to the Beirut blast. We talked to them, try to understand what happened, what can be done better. And then one of the things that you notice here, this is the blast, the center of the blast. You look at on the map. Look at how many hospitals nearby, right? So that is one of the problems, because if there is massive blast here, straight away some hospital, at that time, I think around 9 hospitals were affected. At least 6 nurses were killed instantly. So that is an issue. And the one of the worst thing is that it also, although it's not shown here, destroyed the main warehouse for hospitals, for healthcare in Beirut. So that creates a lot of problem. I think with that, then I think I just give you some summary. Disaster management is one of the important application of maths or operation research. And the complexity of human behavior is hardly represented in the models so far. So we need to include this in the model. We need to include the human behavior. So that explains my my current 2 projects. Yeah. So given the complexity, and we need interdisciplinary research. So I think that's it. And then we can move on to the question and comments. Yeah. So those are my contact. Thank you.
Thank you very much, Professor Stefan Onggo, for giving such an informative and interesting presentation. Ladies and gentlemen, now we come to the question and answer session. I will give the chance to the offline participant to ask directly to Professor Dr. Bhakti Budi Stefan Onggo. Please raise your hand if you have question related to the topic. Don't forget to mention your name and your affiliation.
Thank you, moderator. Good afternoon, all participants in Indonesia, and good morning, Professor Onggo. My name is Jamaliatul Badriah. I'm from Universitas Negeri Malang, Mathematics Department, Universitas Negeri Malang. My question is, see from your talk, we know that there are 4 phases in the disaster management, and when I see your example, you did it one by one, like in mitigation, preparedness, then mitigation, then response. Maybe this question is a little bit silly because I don't know how complex the model in disaster management is, but do you think, is it possible in terms of mathematical modeling to combine all of the disaster management phase in one model? Or yeah, and also I see the heuristic algorithm. It's new for me, but from what I understand it is that this algorithm run in so the termination criteria is when the time is out or you don't have enough time again. Do you think is it possible to add the termination criteria, like maybe this will stop after the solution reach this stage or something similar like this? And then the third question is, what I think is that there will be a lot of uncertainty in the disaster management, like we don't know where the disaster will hit or where. So in your research, how do you handle the uncertainty in the model? And also, for example, in the finding the location for the warehouse, how do you choose it? I mean, if the disaster really happened, for example, in Malang, I think we don't know which location is still be able to be used as the warehouse, as maybe there is a broken in the road or broken in the bridge. So how do you choose the point location in your model usually? Thank you very much.
Thank you. Sorry, I used to call you Mbak Lia. So yeah, good questions. 3 questions. The first one is, in terms of modeling, it's possible, but when you try to solve it, that will become too slow or too challenging. Yeah. And remember, there is a time difference as well. The unit of time is different. Mitigations, typically, we are talking about years. You cannot just change, say, for example, climate change adaptation. It's not something that you can do within days or weeks. It takes time. Yeah. Changing people behavior, that takes time. So mitigation, usually we are talking about years. Preparedness, we are talking about months or years as well. And when the response happens, now we are talking about hours. So that will create a lot of challenge when you want to combine those models, right? So that's why a lot of people seldom combine beyond response versus preparedness. So that is the typical combination at the moment. Yeah. And again, recovery, that takes, I think if I said months, that is fast. You can imagine Aceh, for example. Do you know how long does it take for them to rebuild Aceh? From I think it was years. It's not even months. It was years, right? And the impact of the Cianjur earthquake in last year, right? End of last year, November 2022. How many have they built all the houses? Rebuilt all the houses? The answer is no. Yeah, it's already 6 months, so it takes time. So that's why it's challenging. So that is the answer to question number 1. Yeah. So that's why we typically solve it phase by phase. Yeah. And the second question is, yes, the algorithm that I mentioned to you that I presented was the simplest. yeah, the simplest version of sim heuristic. The stopping criteria can be defined as if we don't make any improvement to the solutions, then we stop it. But of course, we need to have a timeout as well, because otherwise it will keep trying. Yeah, if the system is very unstable. Okay, so that is yes. Remember that is a conference paper, so that's why we don't present the most advanced algorithm. Yeah, so the one that is more advanced, we are still working on it. The third question is really interesting. Yeah, there are a few facets, even though it's only one question, but it has a lot of sub questions in it. How to represent uncertainty? So that there are a lot of methods to represent uncertainty. One of them is that we use simulations to represent the uncertainty. Yeah, so we generate a lot of scenarios to represent multiple futures, possible futures. That's what we use in all the papers that I presented, to be honest. Yeah. Now, another method is in stochastic program. We can use stochastic programming methods. That is the one that I presented for the first one on the procurement, the one with West Java, with Bullock. Yeah, that is procurement decisions. We can use stochastic programming to represent the stochasticity, uncertainty, and in the problem. And also, we also can use robust optimizations. So that's why we compare robust optimization and stochastic optimizations, stochastic programming. And we know, of course, we know, I think mathematician knows that the result of stochastic robust optimization is really conservative, because you are really trying to do the best in the worst case scenario, very conservative. So we know that. So that basically some techniques to address the uncertainty. Now, the next question is really good, Leah. This is something that we are now working on it, still a draft paper, is when we decide locations, facility locations, then we have to take into account that the location can be damaged by the disaster, and most often is a function of distance from the epicenter of the disaster. So you're right. If there is a, touch would not happen, but if there is a massive earthquake happens in Malang, center Malang, then you're right. The facilities around Malang probably will not be usable. So in this case, you have to rely on the facilities in the outskirts of Malang. So that is part of the facility collocation problem. So that's why this is also the issue with the Beirut blast that I mentioned earlier. The facilities are in the city centers. So if city centers hit by that blast, then they were in trouble. So what if we have, the facilities are spread a little bit more, use the outskirts of the city center as well. So that is part of the modeling that we have to do. Yeah. So I hope that give you a brief answer to your very complex questions that probably need a paper to discuss. Yeah.
Thank you, Professor. Maybe I will message you for the last.
Is there another question from offline participant? Maybe one.
Thank you, Mr. Moderator. Good afternoon, Prof. My name is Muhammad Solihin from Mathematics Department, Universitas Negeri Malang. First of all, I would like to thank you for your presentation on one of the operation research application in disaster risk management. It was exciting how you explained and provided example of the disaster management phase, including mitigation, preparedness, response, and recovery. My question are first, can you provide example of how operational research has been applied to assess the cost effectiveness of different early warning system for tsunamis, hurricanes, or any other disaster? The second, what is your advice to government regarding integrating your research finding with exciting disaster management agencies in Indonesia like BNPB, Badan Nasional Penanggulangan Bencana, to minimize the impact of upcoming disaster? The third, how do decision support system rooted in operational research help make real-time decision during disaster scenarios, such as deploying resources to area with the higher priority needs? Thank you.
Okay, I missed the second question about BNPB, but let me answer the first and third one first, and then I come back with the second questions. Okay. Cool. The first questions, the effectiveness of early warning system. I'm sure it has been done, but I don't know, because the thing about disaster management is a huge field. So there are so many papers every day. There are new papers coming in. So this is one of the biggest applications of our operation research. So if you look at major operational research journals, almost in every issue they will have disaster management applications. Yeah, and the effectiveness of early warning system is one thing that I haven't really checked. I haven't really read the literature, but there are similar works that I have seen. So for example, the evacuations. So when there is a tsunami warning at time 0, how long does it take for people to be able to move to a safe, dedicated, predetermined safe locations? Because if you look at in one of my slides, right, there is a route for tsunami evacuations. I don't know whether you remember that. There is a one slide on the, let me just share it for quickly. Oops, can I share it? Yeah. Do you remember this evacuation route tsunami? You have to follow, right? Sorry. Yeah. Oops. Can you see it?
Yes.
Yeah. Yeah. So you can see there is an evacuation route. Yeah. Now, so if people follow that evacuation route, how long does it take for them to move from wherever they are to those locations? So that can be used to assess the effectiveness of an early warning system. So if early warning system only give you 10 minutes, what will happen? If the early warning system only give you 5 minutes, then you know roughly how many people will do the safety. You can have the percentage. So that is quite relevant to your questions, but apart from that, I not because they haven't done, but because this is not my interest at the moment. So I'm pretty sure operational research have been done to do that. Yeah, fairly sure. And the third question there is really good, because now there are a lot of people are working towards digital twins, about the real-time decision making in disaster management. Partly because the technology now allows us to do that with the drone system. With the there is a one mobile communication unit that we can use now, because in the past communication, when it is hit, then that's it. We don't have any internet access at the disaster area. And the solution for real-time decision needs internet access, need the communication facilities. But now with the mobile communication unit, that is possible. So now it is possible. The infrastructure is allows us to do a bit more real-time decision making. Yeah. So there are more and more people are working on towards that in disaster management. Yeah. So it is possible, but I think the research are still ongoing. Is one of the hot topics. So which is good if you are thinking about doing a PhD. That is one of the hot topics at the moment. Yeah. And the challenge from the mathematics perspective is that you need to produce the optimization solutions within a limited time now. Because we are talking about real-time decision making, right? You have to make decisions within 1 hour. So your model needs to run very quickly and to give a decent answer within less than 1 hour. So that is quite challenging for the with the stochastic optimization models. Now, I remember that the second question, I completely missed it. I just remember you mentioned about the NPP. Could you repeat the second question again, please?
Okay, Mr. What is your advice to the government regarding integrating your research finding with existing disaster management agencies in Indonesia like BNPB to minimize the impact of upcoming disaster?
Oh, okay, thank you. Well, if you have some connections, then I would love to be connected. No, but the project that I did in West Java is in collaboration with the with PPPD West Java, the PPPD Java Barat. So yes, we are working closer with them. So that's why we got the data, even though the data are not published data, we got the very detailed data about the disasters, when it happens, where it happens, how many people affected, how many houses damaged, and so forth for 5 years. So we work closely with them. Yeah, so that's how we make sure that our model is relevant to their problem. So the problem that we discuss, that we address in the papers, the first paper, the procurement, is something that we discuss with them as well. That is one of the problems that that they have to decide. Yeah, and how to hopefully we will talk to we will talk to the PPPD. The problem in the past 3 years is when we did the project, it was COVID. So it was not possible for me to travel to Indonesia. But now it's possible. So it's time for us to probably come again, for me to come again to Indonesia to talk to PPPD and BNPP again. And yeah, unfortunately, our contact, the main contact, in PP and BNPP passed away during COVID as well. So our contact with the one of the key contacts in West Java government also passed away during COVID. So there are quite a lot of things that we have. So we need to talk to new the replacement. So yeah, they are. But we are working. So we need to make sure that our research can be useful because our promise is that this research can be that agencies in Indonesia can use it for free, basically. But of course, probably we need to modify a little bit. All the models will be made available, yeah, to the agency who sponsored our project. So if you go to our websites, you can see that they are sponsoring our projects, the PPPD, BNPP, and West Java government. Yeah.
Thank you so much, Prof, for the answer.
Okay.
Yeah, it's a good question, actually. It's a very good question because nowadays, when we do research, especially in Indonesia, I think it's better to do research that can have well, maybe I'm a bit biased here because I'm from operation research, something that can have a direct benefit to the society. So we need to think about what is the real world questions that we need to solve. Yeah.
Okay, thank you, Prof. Stefan Onggo. Unfortunately, our time is limited. For participants who want to ask more about the topic from Professor Stefan Onggo, you can contact him on his email on the CV. Ladies and gentlemen, we finally come to the end of the third plenary session of ICoMathApp 2023. We would like to say thank you again to Professor Dr. Bhakti Satya Budi Stefan Onggo for his informative and interesting talk, and to the audience for your active participation. Hopefully, the presentation will be beneficial for everyone. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Asmianto. Ladies and gentlemen, once again, please give our appreciation, big applause for Professor Dr. Bhakti S. Onggo, a very informative and interesting presentation. To express our thankful, we present Professor Bhakti with a token of wisdom from our department. The hand offering will be done online via Zoom. To the operator, please do the duty.
Well, ladies and gentlemen, in the spirit of united through knowledge, we extend our heartfelt thanks to Prof. Dr. Bhakti, to his invaluable participation. May his endeavors continue to inspire us in the pursuit of mathematical excellence. Well, ladies and gentlemen, we have listened to all 3 keynote speeches in the first day of this conference. Thank you so much for the keynote speaker, and we would love to express our heartfelt gratitude for your insight and knowledge. Once again, thank you so much for Dr. Budi Arta Surya from University of Wellington, New Zealand, Professor Peter Grootenboer from Griffith University, Australia, and Professor Dr. Bhakti S. Onggo from Southampton University, United Kingdom. Ladies and gentlemen, allow me to inform you the general information for the participants. First, participants who are presenter must attend today's plenary sessions and a parallel session as a requirement to get a certificate, while non-presenters must attend today's plenary session as a requirement to get a certificate. Second, participants must also fill in the attendance list via the link provided in the chat room during plenary session. And the last one, also don't forget to all participants to upload presentation slide or PowerPoint files to the link that has been provided by the committee.
Baik, kepada seluruh partisipan, izinkan saya untuk memberikan pengumuman yang harus diperhatikan oleh seluruh peserta seminar. Pertama, peserta yang merupakan pemateri diwajibkan mengikuti sesi pleno selama 2 hari dan sesi paralel sebagai syarat untuk mendapatkan sertifikat. Sedangkan bagi peserta non-presenter wajib mengikuti sesi pleno selama 2 hari untuk mendapatkan sertifikat. Kedua, setiap partisipan wajib untuk mengisi link presensi yang telah dibagikan oleh panitia selama sesi pleno berlangsung. Dan tentunya jangan lupa untuk mengupload slide presentasi atau PowerPoint di link yang nantinya akan disediakan oleh panitia. That is all from us today. See you tomorrow in the second day at 7 AM. Thank you.
Enjoy learning.
And have a nice day.
Wassalamualaikum warahmatullahi wabarakatuh.